pass it to you.
Yep.
You know the clicker?
Test, test.
Test. Yeah, right.
Stand.
What do you want to say? We have to see the slides when they came up too, right?
All right. Good morning, and welcome to Hannover Messe Day 2. My name is Rob Mastrato. I'm the VP of Projects at NGen, and I'm very pleased to start the day off with a presentation today from CGI. Presentation is entitled Accelerating Outcomes with AI, and we have with us today Diane, good to you, who is the VP of Global AI, and Ben Goldberg, Global Industry Lead. So I'll turn it over to you.
Great, thank you very much. All right, so thanks for joining us. There's been lots of talk here at Hannover Messe about digital twins, and what we're going to talk about today is extending our digital twins into digital triplets, and give a little explanation on what that is. So with our introductions, my name is Diane Gucciu. I lead our Global AI Research Center. A lot of the work we've been doing is understanding how we can get value from AI, and I'm joined here by my colleague Ben.
Thanks, Diane. Good morning, everyone. My name is Ben Goldberg. I'm the Global Industry Lead for Health and Life Sciences with CGI. Life Sciences from a manufacturing perspective brings me to Hannover Messe this year, and all the automation and incredible work around digitization and AI. So maybe we'll start things off with a little bit of a background, and how did we even get here in terms of AI? And AI dates back all the way to the 50s, with neural networks actually being built way back then, and the evolution over the years has been quite transformative, all the way to modern day agentic AI. But Diane, maybe you can talk a little bit about some of that transition to where we got.
Right. So as you can see, and I think most people here realize, AI is not new. It's something we've been working with years in traditional AI. And you see a couple of hype curves here. Originally neural networks came out in the 50s, but we just did not have the investment in data at that time, and we didn't have the compute power to be able to really take advantage of it. Coming into the 80s and 90s, when I started my career, the focus was expert systems, decision support, and the real goal of AI and machine learning was to bring information closer to decision makers, to automate processes, to be able to do things with more efficiency in a way that was predictable and well managed. Coming up into the 2000s is when we really saw things take off, and it was cloud computing that allowed us to be able to do more. If you think back in the 80s and 90s, we used to, if we were running a long process, have to put a sign on the computer saying, don't turn off this computer for the janitor, because it took days to finish what in the 2000s we're able to do in hours or minutes. So the real shift is not that the technology is new, and it's not that neural networks, which are the foundation behind foundation models, is new. It's the capabilities and the accessibility. So we're now able to do things that were really complex, really expensive, really time-consuming, in parsing documents and narrative text, in parsing images without having to model them, and to be able to generate information from your own content, not just keyword searches. The other thing that really made this AI's iPhone moment is the ability to use natural language processing. So this whole drive to bring information closer to the people that need the information and not have to have a data scientist interpret it for you, that ground has been broken through generative AI. But even in this last year, the shift in how we use this technology for business purposes is being advanced through agentic AI. And I've heard lots of organizations here that are now breaking into agentic AI. So I'm going to show you. So here's a little running man that I like to use, and we show how we're training these models. This is using Google DeepMind, and it's reinforcement learning for anybody that understands traditional AI. So this little robot character has never seen a person walk before, and it's incentivized to get to the end of the track. So it's run over and over again. The terrain is changed to make it more like real life. And each time it learns, if I fall in a gap, I need to reach over it. If the wall's too high, I need to be able to step over it. And the model is trained with lots of different little figures to be able to get to that end of the track. This is exactly the way we train a lot of our machine learning, in running it in a simulation over and over again against real life scenarios to be able to get it to the end of the state. So if we think about what we're doing with AI now, the foundation for traditional AI doesn't change, but now we have these large language models that have been trained on all of the internet data. And the gap we had with adoption, whether it's in robotics, whether it's in using foundation models through text or through speech, is being able to trust it. How do we know the source information is correct? How do we know that the information is getting us the answer we want, that it's precise, that it's secure? So this is really what we're beginning to focus, but leaning on this foundation of we need the model to perform successfully, doing the task that we incentivize it to do, so that we can trust it. We'll let the little guy finish.
He's going to make it.
All right. So Ben, maybe you can talk a little bit about the progression.
For sure, and this is really fundamentally a lot of where we see how machine learning really began, with the early machine learning around decision trees and concepts there, and then the introduction of the neural networks providing that deep learning for that next stage. Generative AI allows for that interaction to be able to query the data and actually interrogate and learn more and gather more from it. And then the evolution to tomorrow, where we get into multimodal agencies, where agents can leverage other agents to drive different efficiencies and move process forward. I think, sorry, go ahead, Diane.
So I was just going to go into the responsible AI. So again, I think the real key in that progression has been trust. In order to use these tools, again, in robotics and automation and agentic models, we need to be assured it's doing reliably what we need it to do. And the foundation of responsible AI is key. But what we're seeing, both in Germany and in Canada, is a move to set the guardrails based on principles so that we can move towards innovation. So we want the innovation to continue, but we want to do it responsibly. One of the best ways that I've heard of being able to explain how we're going to end up with this responsible AI, which is going to increase our adoption, is using the analogy of water. If you turn on your drinking tap, you know that you can trust your water because there's regulation, because there's monitoring, and if something goes wrong, you're alerted to it. And in order to use AI to help us in decision making, we need to trust the output of our AI the same way we trust our drinking water. And when you look at it with this model, when you get the question of how do we deal with systemic risks of people misusing AI, it comes back to the same foundation of using with water. We need to make sure we're monitoring, we need to make sure we're regulating, and we need to make sure we're continuing to improve the processes. And we build this into everything we do. Again, whether it's robotics, autonomous vehicles, it becomes the foundation of making sure this innovation is done responsibly. But let's jump into a little bit about digital triplets, and we'll walk you there. So Ben, maybe you can talk a bit about generative AI.
Sure. Maybe you'll take this one. The digital twin one I'll speak to, but
right.
Sorry.
Yeah, so the way that we're looking at generative AI is we're looking at it as a service, right? So how this is put together. We have neural networks. Remember, they come back from the 50s. It's been trained on the large internet databases and data stores. However, we take that and we forget about the knowledge and we make sure it has the learning, that it understands the concepts so that it can be used as a service. And in order to do that, it understands the patterns. Again, it's not a keyword search. So just going to get to the next one. And we look at what the tool can do as a service, which builds us up to agentic AI. So if I have a large language model that I want to do something for me when I have a complex problem, the ability to generate, we've all seen, be able to generate knowledge, it understands concepts, everything from synthetic data is a fantastic use of the tool, generate our metadata for our data stores, increase the quality of our data. It can reduce information, so risk assessments, fraud detection, transmutation, so language translation, and other translations like code modernization, knowledge access, and then more emergent behaviors. And we change it from being a tool that we're using to just ask questions to a service that's needed to solve a harder problem. So we end up with this human-agent partnership. which has us instructing, having a question that we're asking, having an instruction in a process where more than one model will work together. And the number one use that we've had so far, going back to responsible AI, is having a second agent be the fact checker for the first agent and be able to increase the quality of the first agent. That's something we've implemented a number of times now, again, to increase the reliability, the adoption, as well as increase the quality of the output. And it's how we're starting to get around things like hallucinations or incorrectly bringing information together. Okay, Ben.
Yeah, this is me. I do love the concept of leveraging the agent to validate the data, though, because that's brilliant in its own right. What we have here is sort of where we've introduced the concept of the digital triplet to really extend the opportunities around the data. So from a pure digital twin perspective, nothing fundamentally new. It's the opportunity to take physical entities, be it a building, be it infrastructure, from my perspective, be it a human being and a patient, and digitizing and creating a digital duplicate of that information. From there, you can leverage all data and IoT sensors to inform that digital twin, and you can run analysis. You can run different types of scenarios just to get a sense of what you could do with that data. Introducing the digital triplet is that next layer on top where you can query that data and bring it really into the next level of interrogation.
Right, and the value of this is not just what the digital twin is doing, because digital twins, you can run simulations, you can do predictive models. The difference is the accessibility. You're having a conversation with your existing investment in data and processes with natural language. We have one client that said, I'm off to a meeting and I'm trying to get information before the meeting. It was a public sector client. I'm meeting with the deputy minister, and I will assign 3 interns and my assistant to go gather the information, put it together in a chart, and they're looking through lots of different dashboards and information to get there. He said, I want to phone my dashboard and have it answer the question on the phone and be able to answer me real time in the meeting. And that's what we built. So the foundation already exists, and you're extending that with the digital triplet sitting on top, which, because it's agentic AI, sits and real time has access to all of that information and can connect the dots. So if we look at an industrial implementation of this, which I'm going to show you in a second, you've got your infrastructure, you've got your resources and your safety guidelines, operations, suppliers, and you can ask it complex questions that you would have had to look at different dashboards or different monitors or control centers to get the answer to. But the agents can go off, gather that information, and answer you in natural language. They can generate your slide deck. They can generate the images and the graphics and give you the information at your fingertips real time. And this has been one of the simplest adoptions of generative AI, because one of the agents as well is the fact checker. It's going in and making sure you've accessed the correct source of truth and that the answer you're getting to your question is accurate so that you can trust it. So just a bit of an example, we'll go through this one quickly. The way the agentic AI would work, the human user would ask the question. And in this case, what are the options to schedule downtime for different assets across my information ecosystem? The orchestrator then assigns the task to multiple agents. One will go generate, one will retrieve the information, one will generate the output. You've got the quality agent, data prep, and all of that information is coming back to that instruction. It works equally well in processes, and you're going to hear lots of agentic AI being able to be autonomous agents that are working through the task. The principles of responsible AI don't go away. It means that the human in the loop becomes human on the loop. You need to monitor the same way you would monitor your interns. You need to make sure they're staying on task, they're generating the information you need, and again, you can use agents to help check your responsible use. So one of the examples we have of digital triplets would be with our machine vision. And machine vision isn't new, being able to have real-time monitoring of all of your assets through drones and still cameras and live cameras and satellite data. The difference with our machine vision is the ability to have a conversation with the data in natural language. So in this case, we're looking at that integrated asset view where all of that data is coming together and is available to be able to ask the question. So some examples that we're able to do is multi-object tracking. So I could say, what is that box on the shelf and who put it there? right? Or you could say, what's the load capacity of that shelf? How many boxes could I put on that shelf? We're able to track vehicles and follow them, and again, in natural language, be able to ask, where is it going, where has it been? If I'm looking at the road congestion or predictive maintenance for infrastructure or asset tracking, again, I'm able to ask that question against it. Some of the things, the little cats are cute, but being able to monitor crowds, and that was the first stage of training the models to monitor crowds, is being able to track someone that looks the same as everybody else in a crowd, to be able to, to be able to detect different actions is really critical. Right now, the biggest implementation we have of this is with railways, looking at scourge and predictive maintenance of bridges and other railway assets, where again, the operators and the engineers are able to interrogate the data to ask, okay, if this was to happen, what would I do? If this bridge is down because of a maintenance, how do I reschedule? How is this going to affect traffic and crowds and all of those things? And again, the key is with the natural language. You're able to have that control center across your ecosystem.
I have a question for you, actually, about the machine vision, because I'm curious to learn more. When you talk about specifics, like certain industries, how is that training done for those models where it's knowing about that data, it can actually interpret the types of questions that you're posing towards it? Because you've got a variety of different industries across those slides.
Right. Yeah, it's a great question, and I think this is where we're going to see a lot more. And I know, Ben, you and I have been looking at some of the small language models, which are models that are trained and fine-tuned on a specific industry.
Right.
So in healthcare, I know you and I have looked at MedLM, which is a small language model, which has a deep concept of all of the different medical coding and different diagnoses and treatment protocols and lab results, but you couldn't ask it, where do you get the best ice cream in Hanover, right? It's not a large language model, it's trained for that. We're starting to see in this agentic that these models are only trained on task specific. And that's really helping with our sustainable models and not having large language models and the amount of compute power needed across that whole ecosystem. Train the model to do the task, monitor, and continue to grow. One of the things with all of these as well is the models are autonomous in their ability to continue to learn. They're always watching your IoT data. They're watching, in this case, the machine vision and what's going on. So you could ask it, okay, how did this change from half an hour ago? Or this happened. Let me know what happened half an hour ago that caused this incident to happen. All right. So this is something we've really seen taken off, the digital triplets. And it's not so much that we're changing how digital twins work, but we're extending the ROI and the value of the digital twin by allowing you better access to the data, which you remember how we've been working on AI for generations has been doing that. All right, so just to wrap up, a lot of the time we get the question, where is this going next? And we have a really great opportunity. We work with a lot of the hyperscalers and the model developers, and the answer is it's up to us. I asked GPT, what's coming next? And AI is designed to do what we want it to do. There's a great quote by Picasso, which is, computers are stupid, they can only answer questions. Well, this is the value of AI to us. But it's up to the humans to instruct it. It's up to us to design what we want these tools to do. And as we have an aging population, as we have a workforce challenges and resource capacity challenges coming across all industries, being able to design these tools to be able to do the more monotonous, labor-intensive tasks so that humans can be creative. So I love when I asked it what's coming next, particularly if anyone's ever washed their cat.
I think I saw that in Hall 14. I could be wrong.
But I think that's a really good cue as we're building these out and you see it going forward. Use AI to do what makes sense in your workflow, whether it's an infrastructure, whether it's healthcare, blockchain. Find the tasks that are labor intensive that can be done easily through this. And don't start with the AI. Start with what's the problem you need to solve, and then ask, do I have the right tools in agentic AI to be able to do this in a new way and do it better? All right, so to wrap up, you know, AI is not going to be taking our jobs, but people that know how to work with AI are going to take our jobs. You know, we are the last generation of people that have only managed human teams, right? From now on, we're moving more and more into hybrid, and I would say in a lot of industries, we're already there where people are using co-pilots and GPTs to be able to assist them in productivity. And it's going to change how we manage our infrastructure and ecosystem. And understanding this, I think, is really critical.
Yeah, fantastic. I think it's interesting. You could look around the manufacturing floor, and suffice it to say, things have changed decade to decade. This is that next evolution that really shows that the way that we manage, the way that we lead, the way that we structure our teams fundamentally transforms, and this is how technology influences the business. It's phenomenal.
This is AI taking your job.
There you go.
Thanks, everybody. Feel free to ask us any questions. I don't know if anyone has any questions.
Thanks so much.
Thank you.
Great job, Ben. Thanks. So how can we help? From an NGen perspective, are you guys looking for connections in terms of?
I think we always are. I mean, CGI is a big company.
j'aurais pu partir, j'imagine. On arrangera ça tantôt. Tu me montreras, je prendrai le temps 2 minutes pour voir comment la caméra fonctionne. Être plus intelligent que. That's what it does. Okay, but merde. Ouais. J'ai dit anomaly. J'étais pas loin.
I think we're good. Remy, you ready? All right. Good morning, Hanover. We are ready for our next presentation, and I would like to let you know that the presentation is presented by Maya HTT. AI in manufacturing equals enabling Eagle Hydraulique to augment production throughput. And I want to introduce Remy Duquette. We know Remy, obviously. We've worked with Remy. NGen has had projects with Remy and Maya, and great to have you here. I'll turn it over to you, Remy.
Thank you so much, and I'm glad to be here today. I hope you don't have jet lag if you're from Canada, but or you've overcome a little bit of it. 1 hour a day is what the research says. You know, I'm data-driven, so I need to look at the data. So my HTT, we've been in business for 43 years. We have long-standing partnerships with various companies around the planet, including with Siemens in Germany. We are the largest industrial AI company in Canada. We have delivered over the last 10 years 175 industrial AI projects, so machine learning, deep learning in industrial environments. So today I will showcase two NGen funded projects that we collaborated with our customers. So you'll see some of the results of that funding, as well as a few other use cases from other clients that we delivered today. So to give you a little snapshot. Of course, if you look at the wheel, Maya does a lot more than just industrial AI. We do a lot in the design, manufacturing, and simulation aspects and PLM components to deliver faster with your design process or your manufacturing process. So we really understand the physics behind all the data and all the different data types, from 3D to simulation results to various simulation of your manufacturing shop floor and process involved. If we look at industrial AI specifically, when people approach us, we first say, what are the current issues, problems, business issues, challenges that you have right now where you would like to apply AI? So before you apply machine learning, deep learning into your environment, it's very important to understand and assess and prioritize which projects, industrial AI projects, should go first. So Maya has, with the 175 projects we've delivered, we know what it takes, for anomaly detection, for quality with machine vision, for predictive maintenance, for energy shaving and forecasting. So various use cases that I'm going to talk about today. So we can accompany you on that journey to figure out what is the best AI project for your company to start with. And sometimes it's small projects, sometimes it's longer projects, and that's why NGen is here, right, to support the bigger, bolder initiative where there's a little bit more risk. So from a Maya perspective, there's really 5 main use cases that we have focused on where we have driven success with our clients in a manufacturing and industrial operations environment. We call it EPIC M, right? E, energy, P, productivity, I, inventory and costing, and then you look at Q for quality and M for predictive maintenance. So if you have one acronym to remember from today, from our talk, it's EPIC M. Choose one of those 5 areas where you have current issues, and we will help you get to the best out of your data. This is the example of predictive maintenance on the right-hand side here of the slide. Often case I'm asked, how will AI help, compared to traditional statistical methods, right? So the statistical method already, if you're asking that question, means you're already a little bit data-driven. So you're at a good starting point. So from a maturity perspective, that's a good sign if you're asking that question. On the flip side, what we have seen is deep learning and machine learning will get 20 to 30% higher performance and throughput than traditional, historically, statistical-based methods. So both have their place, right? And sometimes we'll keep the statistical methods where the gains are minimal with deep learning, and in other places we can apply deep learning to get there. So predictive maintenance is essentially moving that recognition and detection of the onset of an anomaly or a problem very early on, so that you have a lot more time to plan for your maintenance or your change so that you don't get to the disaster in the end. So if you've seen a lot of firefighters on your shop floor, then that's the identification of a problem. So if you have those challenges, if you have those people that go from machine to machine, go from one line to the next, from one department to the next, and run around like crazy cooks, well, then predictive maintenance is eventually where you want to get to, right? But there will be steps to get there. If you're firefighting today, it means you're not data-driven, right? And so it will take a little bit of time to help your firefighters to put down the fire hose for a few minutes, and that's difficult, right? But help put a system in place so that they don't have to take the fire hose day in, day out. So the future is bright, but there is a process to get there, and we've accompanied a lot of customers to get there. Why is Maya, let's say, a little bit different than perhaps other AI companies? One, we focus on industrial AI purely. And the second thing is we understand the data, and we can often simulate onset of failure data with our engineering background. So Maya, 43 years in business, 10, 12 years in AI. But before that, you have 30 years of engineering and manufacturing and process, and in 12 different industries. So when we look at data, to us, it's not just a time series data point, right? A temperature as a function of time, a conveyor speed as a function of time. It's what goes behind that. Is the lithium setting as a function of temperature? Yes, it changes through time, but is it a function of temperature? Is it a function of the pH level in a certain fluid, if you're looking at process controls? So all these things is what makes us different, and where we can build and add to your operational data, which typically is big data, right? But it's very small data when it comes to failure. Fortunately, hopefully. So in those cases, Maya can augment your data set with the onset of failure mode simulation, which will also, if you've listened to the term or heard the term, not predictability, but the explainability of an AI solution and an outcome, Maya can help pave the way, because we can simulate the onset. If we can simulate the onset, we can give certainty to the AI results that it was failure mode 1, 2, 3, or 4, right? Because it looks like, or the closest look-like pattern to an actual onset of a failure. So this is an example where we've applied it. So with Sensei and Domtar, so Domtar allowed me to present this use case for you today. They're a great pulp and paper company in Canada. They have offices, of course, in other countries, but they have a large operation in Canada. You can see the top one is a critical pump. The pump was supposed to be maintained. There was a big maintenance 3 months later. But this here, on February 9, you can see it was heading towards a major failure mode. We picked it up very early in January, right? And then slowly sent some signals to the shop floor workers and to the maintenance manager. And fortunately, there was a weekend in between. So in one of the downtime, they actually went and operated a big change to avoid the catastrophic failure. Had they not done that, the downtime would have been at least a full day, because it takes 4 people for about 8 hours to make the changes that were required for that critical pump. So again, major disasters. The other one, smaller in nature, transformer pins and shortings. So of course these shortings are behind a box, right? So visually no one would see those shortings happening, but they can lead to electrical shortages and outage. So this is an interesting one that we also detected. And the last one is for pulp machines, so a very specific one where it was sloping down in terms of performance. No one really saw it, but if you can see the sloping down, we waved a flag and they realized why they had put some things in manual mode for a checkup and they forgot to put it back in automated mode. So there are all these things that outlier detection and anomaly detection will do for you. This is Eagle Hydraulics. So Eagle Hydraulics has essentially jointly applied with Maya HTT for NGen funding. When we talk about Boulder Initiative, so their idea was to apply AI in their manufacturing shop floor and bring back manufacturing to their Mirabel plant from China. So now they have a full line setup of manufacturing of their hydraulic pistons. And they had 2 use cases for applying AI. One is in the shop floor directly, and I'll talk it second. The first one was simply from the MES data and ERP data. They wanted to get better pricing for hydraulic systems they had never produced, right? So how do you quote a new client that requires slightly different sizes, slightly different things? If it's close enough, you can probably make a judgment call, a human judgment call. But when it's very different and there's lots of options and you can see the list of changes and variables that you can put in the system, it's actually quite complicated. So Maya helped them to build a machine learning algorithm that would continuously learn every time there's a new quote. We can learn a little bit more to better predict and forecast what the real cost will be based on the MES data, ERP data, and PLM data. So we mixed all of that together in the back end and continuously learn from the new products. So that's one of the 2 AI models. The other one is more traditional machine vision. So this was for inspection. So they get a lot of parts delivered to them that were pre-welded elsewhere. And they needed to do the final inspection and checkup of these parts because they figured out that in service there was still quite a bit of defects that were related to the welds. So in this case, we simply built an anomalous detection for welds, bad welds that come in for the inspection to go faster. So, now, just a few other use cases to show you a little bit of the breadth of the type of projects that Maya HET delivers for our clients. This one is on the I side, inventory and costing side. So this is an aircraft parts supplier, so essentially traditional machined metallic machining parts. But the parts are very complex and very different each time, and the volume is not that great. We're not talking about millions of parts for automotive. It's more in tens of thousands for the aircraft components. So quoting became a little bit of a problem. For simple parts, you can quote them very rapidly. But again, for very complex parts, we needed to put a little brain in the CAM automation. So for essentially simulating all the machining steps and the different tools and the number of tool changes. So we can essentially predict how many tool changes, what the tool path will be, and how much time and how much cost it will be for the new part that you've never machined. And then, again, in a similar way to Eagle Hydraulics, we essentially put the price, and it saves them a day out of 5 days of quoting. So there's other things like painting and other things that they need to assess. But in this case, at least, they save the first day is automated fully for that component. pulp and paper, go back to a different company, in this case, Glatfelter. We essentially took 600 sensors, and think of this pulp that's coming in with various raw material, and then after about 30 minutes, you have these huge rolls of paper being, accumulated. Now, in the process, you have a couple of things happening. Your telemetry that you're gathering in time is essentially linked to the quality of the paper produced 30 minutes later. So the raw material that is being infused, the amount of time in the oven, the amount of drying components that are done, the amount of resin that is added, all of this is a complex process and dynamically changing in time. So when you build an AI model in the industrial environment, that's why Maya is a little bit different when I talk about industrial AI being different and Maya being different, and the value that we add is we understand that these telemetry, right, the temperature in the oven, well, for one production, it might vary from 12 minutes to 12 minutes and 8 seconds in terms of its impact to the 20 quality parameter downstream. So those dynamic behavior need to be baked into your AI model. Otherwise, garbage in, garbage out. If you don't have the right inputs that are correlated with physically and in the reality to the outcome, the quality parameters, well then your model is not going to be good. So this is one example where we were able to predict at very high percentage. A lot of people tell me, for low production, right, we can't build a lot of AI models. In some cases, that's true, but in many cases, it's not. In this case here, we have composite parts for aircraft, if you recognize the parts. So there's many, 40 to 60 layers of composite material that are being applied. Even though it's robotic, right, there's a lot less manual mistakes made, of course, but there's still mistakes in the sense of the tape might be twisted. The machine doesn't know that. It will just, lay it down. Maybe there's too much resin, not enough resin. So if you build up these little defects and you accumulate them over 60 layers, well, guess what? If you wait to the end, you're going to have a big problem. And before you go to the oven, you're going to bring in the engineering team. They're going to say, okay, do we cook the parts? Because then it's a huge expense for nothing. And then, or we're going to cook it and figure it out after. And then you have a huge rework, to be manual rework. That takes a week or two in some of the cases. So all that wasted time, you can avoid it by putting an AI model there fed by the telemetry. That was the first project we did. So pure telemetry with the 29% defect detection. And then we put a camera, right, as an add-on later, as a second project. Again, we do it in small phases, right? We didn't, for the first project, we didn't touch any sensors, we didn't add anything, right? We just did a first project to help them a little bit, to see the value that they would get just with pure telemetry. And then we added the obvious sensor that was missing, in this case, a video as a sensor, as a camera, that would, visually confirm what's happening behind the feed. Sayona, another NGen funded project. So in this case, a very interesting machine vision component. So these 1 meter core samples, as you see them here laid down, so it's kind of, we're seeing it from the top, right? But it's a round core sample that you pick out of the ground. So they drill through the ground and extract these core samples to understand how much spodumene, how much lithium, right, crystals, are in the ground. Historically, that drives two different manufacturing processes. So depending on the crystal size and the amount, right, you're going to use one process versus the other. And the earlier you can figure that out, then the best you'll be, because you will actually feed in the low-cost manufacturing process first, if you can, and that will save a lot of money both in the design and the manufacturing and the plant construction than anything else that they would have to do. So in this case here, you can see the AI machine vision, pure high-resolution cameras with ultraviolet feed. So as you go across, you take these images, and we automatically essentially recognize how much lithium is in these, and we save in time. It's 65% faster than doing it the old way. Okay, and the accuracy, you can see how accurate this is against the ground truth in a case that we had not, of course, seen in training. Common mistake, by the way. If you see results that are too good to be true, they're probably too good to be true, so they've probably been part of your training data set, so just make sure your data scientists don't do that. In this case, it's a pure out of sample, so you see the green is where we detected spodumene, and it is spodumene, and in blue, it's false negative, so there was spodumene, but there is actually no detection. And on the red, it's false positive, so we detect spodumene, but there's none. Okay, so that's the nice result that we got. We're just closing out the project now with them, with NGen, so thank you so much. That was awesome. Great results. The company will now, benefit a lot from that technology, and they're rolling it out at scale. This is, once you have the spodumene and you have the lithium, now you can produce batteries, lithium batteries for electric cars. Discrete manufacturing, 16,000 inputs, right, in 10 different manufacturing stages. So this is a massive amount of information that needed to be gathered so that we can predict the quality of the batteries. And in doing so, we figured out that one of their biggest concern or problem, business problem, was the fact that they had to build a third line of manufacturing because their throughput was not good enough. And what we said is, well, wait, because the amount that we can actually accelerate based on the results that we have, we think we can actually avoid or postpone your capital expenditure by a significant amount of time. And in this case, we were able to help them with a 10-hour reduction in production time per battery. And that was good enough to push out by at least a year the new line expenditure. So the capital expenditure that would have been tens of millions of dollars was able to push that out at least a year. So that was a great win. Initially, we were there for the quality, because the variance in quality of every battery that's produced is still fairly wide, from the best battery to the least performant batteries at the end of the food chain. It's still a lot of variance in there for perfect and beautiful, same manufacturing 10-step process. There's still things in the process that are difficult to control with lithium. One that's a little bit more on the industrial operations side. So if you're from Toronto, you recognize Enwave, the logo. They essentially move the water from the Lake Ontario and move a huge amount of water under the buildings in what we call district cooling and district heating. So they're heating and cooling the buildings with a huge amount of water. So think of small or very large versions of your heat exchangers for the entire buildings in Toronto downtown core and a few other areas, hospitals and other critical facilities. So we help them move from spreadsheets. If you have spreadsheets that are propagating like rabbits all around town, maybe call us because we can help you move away from spreadsheets that will inevitably create some manual errors and other disasters. It's always, you never know what you have in those files, and it's definitely uncontrolled data is never good. It might be good data, but you'll never know if it's the latest data, the latest version or whatnot. And everybody will take a copy out and do something with it, and then somebody else will do something else with it. Anyway, that's the rabbits analogy there. But in any case, moving to a data environment that is stable, there's only one source of the truth of the data that you're collecting. And then you can build a bunch of apps or put a system, integrate other systems to make sure you manufacture that properly. So you see the forecasting here. This, again, out of sample data for a full day, predicted the day before. Okay, so these two traces are the actual of that day versus what we had predicted essentially the day before, 24 hours before. If you look at the supply and demand, we're pretty close. We have 91% explanatory power. We used some very sophisticated graph neural networks that were mimicking the hydraulic network in place. So very sophisticated elements of data science and machine learning here applied for their use case. The benefit is we had put in place all the data acquisition and the monitoring. So the data was actually extremely well organized. The data pipelines were very well orchestrated. So it was a little bit easier to build those sophisticated deep learning components. This one is more for the visual, so you understand what reinforcement learning does. I would not recommend reinforcement learning to everybody, right? But when applicable, it does wonderful things. So you can see when we turned it on, the controller was a PID controller. So what you see on the left there is a PID controller loop that essentially always tries to chase the signal. So it's very noisy, right? The swings, the mechanical swings in this case, are very, very high and very high frequency. That induces a lot of fatigue, right, on the parts that are being used in the system. So when you turn it on, you see a lot less fatigue. Actually, the number is 32% less fatigue on the parts. And in turn, that elongates the life of the part. In this particular case, they had challenges, again, business issues, to replace components every month or every 2 months. And after we've applied the reinforcement learning component, and by the way, we safeguarded with the PID controller loop in the back end. So we just put an if statement in the PID controller. And when you were within certain ranges, we allowed the system to run the reinforcement learning. And in this case, 16 months without a failure. So it shows you a direct, gain of an AI model being addressed in industrial operations. This is our friend. These are our friends at the Canada Steamship Line. We've been in business with them for at least 7 years. We presented publicly together on multiple stages worldwide. So they've always allowed me to present a little bit of the results. So they have 40 to 50 vessels roaming around the planet. Initially, again, very manual entries, a lot of data loggers that are from captains and other people that would manually log information, a lot of very useful information that should be kept. And so in this case, we completely digitalized their fleet. So we did a first data acquisition project with them where you go through SATCOM or LTE when you're at shore. So various things there to bring the data into a central location. And now we're embarking, it was announced last week by the Ocean Supercluster, into a 3-year multi-million-dollar projects for building predictive, AI-based predictive maintenance for their fleet and for C-SPAN fleet as well. And the last one here is from Thales. Again, same thing. It's in the predictive maintenance aspect for vessels, the vessels that go up north, icebreakers and other components, where we are in charge of all the AI-based predictive maintenance for the marine vessels. So they've allowed me to present that one slide to you. If you have questions, you can simply scan the barcode or the QR code here, and you can get to various information points. My email is on the left-hand side, and if you want to access our website or the AI readiness assessment, you can scan those codes. So on that note, thank you for your patience here, and glad to see you guys. I'll be at the booth right here with my colleague Nicolas if you want to further discuss any of your industrial AI projects. Thank you.
how do I change this with this one and that one?
This is the one that to change it. I think this is the laser pointer,
Okay.
and this is if you want to go back.
Okay, perfect.
Would you like me to introduce you?
Yeah.
And you're, NGen, me too.
No.
No, neither am I. They literally printed everybody.
Farming technology.
Famic?
Yeah.
Yeah. And you are based in Montreal?
Based in Montreal, yeah.
Good. And do you have a booth or display?
Just here.
Okay, great.
So we're just. So if
All
people
seven?
wants to come, yeah, all
Yeah.
7 D28s. With people can just come here. Just come in there.
Where do we find that on the app? I don't know. Just so like for
Joanne would know
Yeah.
better
Okay. I'll
than I
ask
do.
them. Then I wait. Thanks.
Good to go?
I'm good to go. Waiting for the screen to turn on,
Okay.
but otherwise we're good.
Do you hit the... Just to get the...
PowerPoint on.
As soon as he's introduced.
Oh, okay, great. Wow. Good morning. Coming to us all the way from Montreal, Quebec, via Hall 7, we have Erwin Deschamps of Famic Technologies, and I'll let you take it over. Thank you.
Can you hear me? Yeah. Okay. So welcome everyone. And I'm Erwin Deschamps. I'm regional manager at Famic Technology. And today I'm going to talk about digital twin modeling, simulation, and analysis of multi-technology system. So as you may all know, the industry must deliver reliable products using efficient method. So what we need to do is we need to boost our productivity, but also reducing all the loss and minimizing the downtime. To do that, we need also to increase our active collaboration across different departments. And we need to enhance people's safety while at the same time optimizing the quality of our product. Of course, we need to ensure environmental preservation, but also we need to improve the communication with technical support to resolve all the plant issues more quickly and more effective. So how to develop and use a digital twin to meet these challenges? So first, I'm going to quickly introduce what is the role of a digital twin in the industrial environment. Then I'm going to show you how you can develop a digital twin with the solution that we have developed, Automation Studio. Then I'm going to show you what kind of advanced analysis you can do from that digital twin. And at the end, what is the most important, how you can share all this information with all the teams and all the departments. So first, definition of a digital twin. So there is many definitions that exist to explain what is a digital twin. For more than 35 years at Famic, we have seen a lot of our users who at some point wants to create a digital twin of an HMI, a control panel. Some wants to create a digital twin of ACU. Some wants to go for component and subsystem. From the component and subsystem, then they want to create a digital twin of a machine, a complete machine. When you have your machine, then you want to create a digital twin of the environment in which it's working on. For example, if it's on a paving system or a road system, you want to modelize the icing on the roads and how your system is going to react. If we are in the industrial world, if you have a boiler press, or you need to understand how the system is going to behave where there is a heat source. If you are in the offshore industry, if you want to have a wave compositor, you need to create the waves first. So you see all of this is kind of digital twin that you can create. But for us, what a digital twin should be? First, it should be trade-oriented solution, which means that no matter which industry you're working on, it should be adapted to what you're doing, to your industry. So it could be industrial, it could be car factory, it could be transport, it could be material handling, wind turbine, energy, aerospace, no matter what. Then you need to use smart components, which means that they should be not only drawings, it should have parameters, it should have data in it, so you understand how the system is going to behave. Then you need to deal with different standards. For the drawing part, of course, there is for hydraulic and pneumatic the ISO 1219 standard that you need to use. But for electrical, in Germany, you use IEC standards. In Canada, we use NEMA. So you need to have all these standards at the same time. If you are in the process control, it's the ISA 5.1 standards. So you need to have a digital twin adapted to all these. Then it should be used by all people in a machine, involved in a machine, which means that you don't need to be an expert to create a digital twin or to use a digital twin. Yes, you might improve it with some more expertise, but at some point, everyone in the company should be able to use it. It should be kind of a machine knowledge manager, where all the knowledge of the system or the machine should be inside that digital twin. And at the end, you should be able to combine every technology available on a machine, which means that you might have some hydraulic, some pneumatic, some electrical, some robotics, some automation, but all of these, they should talk together. So what is the basic common work process that we are currently seeing? There is a lot of CAD software that exists. Then, when you have made your design concept, you're going to go on the simulation part. But for the simulation part, there is also a lot of software that exists. But to go from CAD to the simulation, you need to redo the work. Then you might want to go to the code simulation, implementing some hardware in it. But if you want to do that, maybe you're going to use another software. And then you're going to have a prototype. You're going to go step by step, and at the end, you will have the production of your machine. But the simulation after also is not really used for the training, technical, and diagnostic. What we saw is currently the common work process is at every step, everyone is working in silo. There is no communication, so everyone has to redo the work of his previous colleagues from another department. So people in training need to redo the documentation or the design. People from documentation need to redo the work from the R&D team. So what approach we have developed at FAMIC? It's an all-integrated development solution, which means that no matter which department you are, could be from the design, maintenance, technical, sales, you are all looking at the same machine, which means that you might have different goals, different objectives, different perspectives, but you should be able to work with the same tools. So our solution is first to start with a design concept. So we're going to use digital twin of components. From there, you will have your simple schematic. And then at a very early stage, you're going to choose with manufactured components, which means it will be components coming from different brands with data, with parameters. So you're going to implement that manufactured component at a very early stage in the development of your machine, which making also very fast the development and the validation of a prototype. So if you have some change to make, you can do it very early. Because what we saw is if you're arriving at the production level and you're starting to find problem, this is where it's the most cost about times and money to redo all the work. So our objective and the approach we have is really to have the components and the manufactured component at the center of the design of a machine. So basically, the component will be ready to simulate. the component would be like with symbol and manufacturer's data. The components, you can have access also to builders with all the options available for from a manufacturer, which means that you will be able to select. If you select another option, you select another option, then you can directly see if that option is good or not. You don't have to buy it and test it. You will do live. Then you will have access also using that virtual test to make these tests. Having access to 3D like representation, because these components and representation, then you're going to integrate in your 3D. It will be linked also to all the data sheet documentation and sizing sheet. When you have your component, your system made, then when you want to do some code simulation, you might integrate the logic. So the logic could be done inside the software that we have developed, Automation Studio, or you can do and make some code simulation using OPC. So, for example, if you have a case where you have a machine and you want to have a new production line on your machine, what you're going to do first, you're going to have the mechanic team who's going to make the improvements on the fluid part, the pneumatic, on the hydraulic part. But at the same time, you can have the automation team that can work on that. They don't have to wait that the machine has been done to start to doing the logic. Everything could be done very in advance. So when you are going to start implementing the solution, all the tests has been made in advance. So it's going to reduce a lot the time you're going to stop the machine to add the new production line. I'm going to show you a couple of examples of, and first is the bottle filling station. If you want to see the system working, we are the all 7 D28 where we have this machine running. So this is an example of an electro-pneumatic system. And on that system, you will be able to see like flow. You will be able to see pressure. But with that flow and pressure, you will be able to calculate the energy consumption of your compressor, for instance. And if you see that information, because you will be able to calculate over the time, you can see how much does it cost for you, that type of machine. So basically, you will be able to see for the same machine, using the simulation and the digital twin of your machine, how much it costs to produce in Germany or in Canada, because you will be able also to adapt and by knowing the cost of the energy. You can do also some FMEK analysis. So this is a concept, the FMEK, that has been there for many years, starting more in the like defense and aerospace industry. But now we saw more in the industrial part, people are using it. So if we retake our concept, first, you get your components, you create your digital twin. Then using the FMEK analysis could be done for two parts. First, what you're going to do, you're going to create functional groups where you're going to divide your system function. Then you're going to specify different operation mode. From there, you will have automatic measurements of nominal performances. When you have done all this work, what you're going to do with the simulation, you're going to put some defaults inside your system. And by putting some default, you will have a failure mode analysis and report. Because you will be able to compare your system when you don't have a problem, the system when you have a problem. Then there is kind of two ways of using it. If you have an early stage of the design of your system, it will help you to improve your system. Maybe adding function, adding component, adding security. If you have already done your machine, but now you are more on the side of the maintenance parts or training parts, with that automatically made report, you will be able to put the causes of the system. You will be able to see the global or local consequences, severity, occurrence, all of this could be seen. So this then could be shared to the maintenance and the troubleshooting technician to improve their skills, to reduce the time of diagnostic. So this is an example of digital twin of a boiler press that we also have. Here you will be able to see some system performance with some curves. You will see some design with manufacturer components. And here you only have the hydraulic, but of course we have also the electrical part and a sequence that has been made. So now what's going to do is when you're running the simulation here, you have a first design. So what we do with FMEA, we're going to evaluate a sequence and see how my system is going to behave with that first design and nominal performances. So for example, in that case, the first, you will get 51 hashtag per minute of that the system is going to run. Then what you're going to do, by using some layers, you will be able to have multiple other design. Then we're going to take another design, more complex, with more components. And what you're going to do, again, the same simulation. And now you're going to see what would be the performances of this second design in simulation. So it's going to help you to make a decision for your design. It's going to help you to make a decision for the choice also of components. So what we saw is for that one, for example, we have 81 hashtag per minute. So we know that the second design is better and more efficient than the first one. So the second design has been approved. The FMEK analysis, there is a lot of benefits in it, with combining with a digital twin. First, the first benefits at the high level is for cooperation, is to enhance decision-making and maintain security and productivity inside the company. Then also it's to democratize this working process. And of course, it's to reduce the cost of this process. For design department level, it's to avoid costly modification by identifying at an early stage where the problem could be. Then is to check if we need like redundancy system, operational stress, fault-safe mechanism with that FMEK analysis. And then is to improve and make stronger the design process. At the more maintenance department level, is to have something which is completely automate failure mode analysis. It can replace manuals. Doing that type of analysis takes a lot of time, where you need to be inside the room, where you need to talk with people to understand how the system is going to behave. This is done automatically with Automation Studio. Then it's going to give you a comprehensive insight into the failure mode consequences with relevant plant information based on your system. Then it's going to create and generate automatically a tailored failure mode report on specific search criteria, which can help you when you have a problem on the machine that, OK, I've got an issue here. What I'm going to do, I'm going to use that report. From the criteria, I will be able to find different causes. And finally, it will help you to communicate relevant information efficiently and potential solution to mitigate failure impacts on the plant. What is the most important as soon as you have done all these analyses is to share the information between departments. And this is the most difficult thing that we saw and which is the most costly for a company. Because when you have a digital twin that you can do very easily, then you need to share that information to every department. And with Automation Studio, what you can do is you can take that digital twin and send directly the document to the after-sale and documentation departments, where you will have automatically made bill of material, where you have all the component failure mode, specification, maintenance information, warranty. All of this could be done with the software, integrating in the software. Then you can take that also and send it to the training departments, who's going to use that drawings, not having to rebuild it, just use it as it is, because you will have also a lot of already made information with color, animated circuits, with illustrated view, with sectional view, and some activities with workflow that could be done. And also at the end, sharing with videos. You can just automatically having MP4 format videos that you could be shared to any users. And finally, as I show, for diagnostic purpose, so FMEA. I hope you enjoyed that presentation. I don't know if you have any question. Otherwise, so we are all 7 D28s. We have all these projects available and many more.
We have time for a couple questions, but if you're not, you know where to find
Okay.
Erwan and his team. Thank you, everyone.
Thank you very much.
Erwan.
Thanks.
Very much.
Thanks.
We'll be back at 11:30. Correct AI.
All right. Good morning, Hanover. And we're all set to go with our next presentation. This one is from Correct AI, entitled Artificial Intelligence, Real Safety and Efficiency. And this one comes all the way from Edmonton, Alberta. Came a long way, Siamak. So we have with us today Siamak Akalagi, CEO of Correct AI. And before I leave, I just wanted to tell everybody, Hall 17 is where you can find these guys. Over to you. Try that again? Oh, hang on. Time out. We just need to get some technical issues sorted. You want to try testing?
Okay. Yeah, it's better. Okay. All right, thank you. Well, thanks for the introduction, Rob. Appreciate it. It's a pleasure to be here and speak with you. My name is Siamak Akalagi. I'm the CEO and founder of Correct AI. Correct AI is a relatively young company based in Edmonton, Alberta, in the Western Canada. What we do is that we use AI technology for earth-moving applications. So that could be for the agriculture, for mining, heavy construction, and so on. Most of our activities right now is mostly in heavy construction and mining. In that sector, there are different areas that is of interest to customers or users. One is the safety, the other one is efficiency, productivity. And we are trying to use AI for that purpose. As probably you know, is that in the heavy construction, there are so many blind spots, heavy equipment, so many interactions between the metals, metal to metal or metal to human, congested areas, and unfortunately sometimes there is accidents. And when it happens, it's quite costly. It's a very difficult situation for the families, for people that are involved, with the project owners or contractors. And we are trying to address the issue with the AI to see how we have to avoid having safety issues at the job sites. For that, people have been working on it, and we've been trying to develop different products for that purpose. And the very first approach was just to rely on the human, on the operator, driver, to look around, make sure that there is nothing in the blind spot, or have a spotter in the back of the vehicle to give guidance. And over time, people started to think that maybe we should start using technology, just like the backup alarm, or start to having passive solutions like mirrors to put all around the vehicle to give visibility to the operator that where they don't see properly because of the design of the car. Lately, people started to use passive sensors like cameras or radar technology, but the problem with that is that they give you warning for something that is in the blind spot, but it doesn't tell you what is that. So that obstacle could be human, or it could be a pipeline, or it could be a tree. And when you operate a vehicle for 8 or 10 hours a day and the system beeps at you every 5 minutes, you're not going to pay attention to it anymore. You're going to start ignoring it. When you ignore and there is a real person over there, or there is another metal over there, another vehicle, then it's going to be quite costly. So our approach is just to have the park side to use a camera or camera LiDAR technology just to see where operator cannot see, and using AI with computer vision to differentiate between what is important and what is ignorable. And what I mean by that is that most of the, for instance, mine sites, they don't have people on the ground, but there is another vehicle in the blind spot. So we set the system such that it would give the warning for other vehicles that are in the neighborhood or in the adjacent areas. In the construction sites, you get a lot of interaction with people. So our system would set up for a human, and then would ignore all the other things that you don't want to get alarmed for. So our system is quite advanced. We try to use cameras, stereo cameras, just very much like your eyes. So there are two cameras that would give you some sort of perception for the distance as to how far is the obstacle from you, whether it's to your left, to your right, and whether it's 5 meters away or 20 meters away. And then it would, based on that, we define the scenarios that we need to have to control the operation of the vehicle to avoid the collision. And if there is a video here that shows you in basically how the system works, there is a, for this case, it's the excavator. We put a stereo camera in the blind spot in the back of the excavator, and there is a monitor sits inside the cab that gives the warning to the operator. And it would identify the risk. Human would be red, vehicle would be green, or general obstacles would be blue, and then gives the operator a warning that there is something in your blind spot. And this is the entry-level solution. We have the more advanced solution. If operator doesn't pay attention, we do assisted braking. Basically, we stop the vehicle or slow down the vehicle. So it's more like an autonomous solution that we have developed. In addition to that, what we do is that we collect all the data that we gather from the operation as to what are the safety intrusions that happened in the red zone, in the yellow zone, or in the green zone. And all this information is stored locally or sent through RF network to a cloud server, and the operations management or the HSE, health and safety authorities, can view what happened with their equipment. And then over the week or over the month, you can, when you have so many equipment that are running, you gather all this information and gives you insight as to what's happening at the job site. For this specific case, for a mine, you could see that there are so many interactions happening on Mondays. So safety manager can go and investigate as to what's happening on Mondays, but it doesn't happen on Tuesday or Friday. So he starts to gather more information through your operation. In the regular time, most of the people are just ignoring it. There was no report, so there's nothing wrong with the site. But when you have all this information, you start to learn that statistically there is a more chance of accidents on Mondays than any other day of the week. This is another example of their product that is for a mine that is in Chile. Here you could see that there is a loader that is backing up. There is a pickup truck that is going behind the loader, and the driver is not paying attention. Our system stops the car. It doesn't let the loader to go any further because there is a high chance of collision. As you can see, the loader was stopped as a result of basically the recognition of the vehicle that is coming to the back of the vehicle. Now, just imagine if you have this assisted braking with no AI. So all of a sudden, you have the safety solution, but safety solution doesn't let you to do your operation anymore because it stops all the time for anything, whether it's a fence, or it's a vehicle, or it's a human, or it's a cat. So the system is going to stop, and that comes at the cost of the productivity. We try to make a marriage between safety and productivity with using AI. Now, the same system that we use it for collision warning, that has camera and LiDAR, also can we have the GPS data, we have the camera, we have the LiDAR data, all of a sudden we have a mobile map. So the same system can be used to map your site as to what's happening at the site. So here's the one example, is that the camera LiDAR that was installed in the front of the haul truck also can look at the the stockpile in front of you, and it would do volumetric measurements and give you the information as to of the volumetric measurement as to how much material you have at point A, or during the construction, how much material you move from point A to point B. So you don't need to do surveying anymore. Basically, your collision warning system can do your survey basically work as well. In addition, at some of the mine sites, they always have the berm at the side of the haul roads. And these berms, they have to be meeting the certain standard in terms of the height and the width and all of that. Our system can scan the road and would tell you if there is any violation of the standard in terms of the berm height, and would give you all the information to the management. And that, you know, while I was doing the collision warning, by the way, I noticed that there was something wrong with the infrastructure, and give a warning to the operation. The other thing that we are doing is that, again, we are using our AI for monitoring the behavior of the operator. In the mine site, when you operate 10 or 12 hours a day, when you do a routine work, there is a good chance that you get distracted when you work in the remote areas. And that comes with the fatigue management. That could cause a lot of issues for you. And so most of the cameras that are in the field are just a simple camera that is installed and monitors the behavior of the operator and give you warning that if there is any violation. But the challenge is that if they're, for instance, they're not wearing the seatbelt, or they're smoking, or they're on their cell phone. So in order to address that, we use our AI to say that actually there was a fatigue here because he closed his eyes for more than 3 seconds. So it is well trained and recognizes the behavior as to what is the threshold and what if the operator is exceeding those thresholds, and they give meaningful information to the dispatch room to go and take actions. So this is another product that we've developed. Is again just the software that goes with the hardware of the third party. Our AI is only monitoring the management and the management of the operator, or basically how they behave in the operation of the vehicle. That's in summary as to what we are doing and what the products that are launched and that are available in the market. And yeah, if there is any questions, more than happy to answer that. Thank you. Thank you, Rob.
I do have a question.
Sure.
I'll ask on the microphone. Question I have, I see that the application obviously is for mining applications, earth movement. Do you see an opportunity for this to be moved into warehouses or manufacturing facilities, for trucks?
Yes, definitely. For the warehouses, for lift trucks, it's the same product, the same functionality. We just bring it to the control environment, and basically with the area that there is no GPS. Basically, we do have our products are working for either underground mine, or for the warehouses, or for the open pit, basically open sky conditions. So we do have different versions of our product for different applications.
Excellent.
Thank you.
All right. Thanks so much, Siamek.
Thank you.
And then once again, your booth, Hall 17.
Thank you.
All right. intimidating.
Exactly.
All right. Good afternoon, Hanover. We are about to start the afternoon session, leading off with a presentation from Engage Automation, coming all the way to us from Cambridge, Ontario. Great to have you here. This afternoon we have Jeff Kaufman, Director of Sales from Engage Automation, and Sean Elder, VP of Operations from Engage. Gentlemen, I'll turn it over to you.
Thank you. Thanks, Robert. We are Engage Automation. We're a control systems integrator from Cambridge, as Robert said. We provide electrical design and software development services to our end user customers and turnkey systems along with our mechanical partners to our customers as well. Like many systems integrators, we are constantly developing internal tool sets to help us do our jobs better, maintain accuracy and increase efficiency in our internal processes. And what we're going to talk about today is one of those tool sets, and specifically our 3D model and 3D simulation and digital twin capabilities. Jeff's going to focus on our how fast we can generate those digital twins and how the digital twins are used throughout our engineering process. Well, we start using them as early as the quoting and estimating phase of the projects, and then all the way through the project lifecycle. And how important they've become to our business and our processes. Go ahead, Jeff.
Yeah, thanks, Sean. So we started using 3D simulation about 7 years ago, and the primary purpose was virtual commissioning, process simulation, flow studies. So we wanted to have the ability to test out our PLC code on large systems that were impossible to basically set up in a shop before they got installed in the factory. And it was used to great success. And through the process of that, we kind of started thinking, what are the other options and how can we continue to leverage that information or that tool set through other aspects of the process. So we started by looking at the traditional project execution lifestyle. So you start at estimation, do a bit of engineering if you're going to do the job right so you can be accurate. Then ideally win a project, move on to electrical design. Hopefully that team uses some of the estimation information and continues forward with the process. When they're done, they kick it over to PLC programmers. They start their own spreadsheets to track their own information. They do their chunk. They move it on to HMI, et cetera, all the way through to documentation. And really, the arrows are very intentional, very unidirectional. Hopefully you don't get further on into the process and a mistake's found or modifications made, because it really does feel like you're swimming upstream to try and push that information back to the other departments to ensure that you have a complete and accurate design. So by putting the 3D model at the center of the design process, we've been able to locate it as one source of truth for the entire project. So by having the 3D model in the center, at the quotation phase, you can highlight out and outline the project, and it gets put in the model. Then, when you move on to the electrical design and more information is added, that information is also added into the model. And that just continues throughout all the steps. The nice thing is when you get to something like simulation and you find out that you need to modify the design for one reason or another, you can directly. It gets pushed back into the 3D model, and then each one of the prior steps, estimation excluded, can pull that information back out and update their schematics, update their code, update their HMIs to ensure a completely accurate project all the way through. The key part to that, and in order to use it effectively, is we had to come up with a way to rapidly develop these 3D models. So quick so that we could afford to build these things directly at the quotation phase. So the method we took for this is a AutoCAD annotation process. So we would get 2D AutoCAD files from our end users, and then using a series of in-house designed AutoCAD blocks, we could quickly outline that process, and then through the use of our 3D toolkit, pull all that information into the toolkit, and then with a click of the button, output a 3D simulation model. You would have noticed from that last slide is that annotation process is very simplistic. It's basically a single line drawing with start and end points for, in that case, a conveyor system. What it's missing is all of the other supporting equipment that might be required for that, whether that's field devices, motor types, disconnects, control panel locations, wire routes, etc. We could have built all that in, but then that's adding complexity. That's adding more time that someone has to take to apply that to each individual conveyor model. It's also not terribly scalable, because if you've got a system where it has 10 conveyors, that's not too bad. But if you have one that has 500, now that really increases the overall amount of effort you have to put into it. So what we did is, again, through the toolkit, applied a series of templates that can be quickly applied to types of conveyors or types of elements, and define each one of those elements so that they're consistent throughout. So instead of having to define 500 unique elements, you might have a conveyor system that has 3 types of conveyors in it. Clearly and accurately define those, apply them to all of your elements, and you can quickly generate an entire model with all of the individual components in it. The next step, or the next obvious addition to that 3D toolkit, is that, well, now you've got a 3D model that has every single component in it, from source to load or source to sensor. And with that, you have everything you need to be able to automatically generate load lists and I/O lists that can be immediately used. So eliminating some of those siloed spreadsheets and helping speed up the engineering process. The other nice thing is, because all the information is there, including physical locations, how they're being installed, now you can do design validation checks based on the model to ensure that your design is not missing anything before you even get into the schematic phase. Again, another natural addition to the toolkit was to define the system architecture. You have all the components, you have everything put into that model. Now we can use the simple drag and drop architecture to define the system architecture, from power distribution to sensor distribution and communication architectures. Once all that was in there, now you have the makings to be able to generate all of your schematics. Because you have from source to load, everything's designed, everything's architected, that effectively gives you the groundwork for your 3D schematics. Instead of then passing that across to a draftsperson, why not just have AutoCAD read in from the 3D toolkit and automatically generate all of your electrical schematics directly from that 3D model? Again, keeping the 3D model and the toolkit at the center of the design process, the only source of truth. Another addition to the toolkit that, if anyone's ever developed one, would be a massive benefit, is a tool to determine cable routing. Again, all the devices are input in the model, all the raceways there. So what we did is develop an algorithm that automatically calculated the shortest path from point A to point B and lay in those cable directly into the routing. It also respects voltage segregation and communication type, so it can keep, for instance, 480 separate from 24, separate from communications architectures, and quickly and accurately output a complete cable schedule with lengths and part numbers that can be immediately used. The other benefit is, when we all have indecisive customers, and you get to the time of commissioning a project, and now a control panel is moved 50 feet to the west. Instead of having to kick that all back to an engineer and them grumble about redoing all that work, it's a simple click of a button and it completely regenerates that cable schedule for you, avoiding delays in project commissioning and potential downtimes or extras. Well, now all of the electrical design steps are incorporated into the toolkit. It wasn't a big leap to move on to the PLC and the software development side of that. With the electrical schematics, with knowing all of the line numbers, it was very easy to generate your I/O list and your tag information for the PLC program. Then applying a similar method of templated PLC code, the 3D toolkit can now automatically generate the PLC code for the 3D model that's been previously defined. The template-based approach means that it's adaptable for multiple customers across multiple standards. If we work for different end users or different facilities, we can take that modularized code and automatically apply it. And then if, for instance, if it's a repeatable system, you can then move it from one facility to another with a click of a button by applying a new template. Again, for anyone that's ever had to develop one, a favorite utility of some of our software developers is the auto-generation of the HMI screens themselves. So going directly from the AutoCAD annotation into the 3D model, and from the 3D model directly outputting, in this case, Rockwell FactoryTalk View SE and ME screens that can be directly imported as is and are fully functional. All of the animations, all of the tagging, all of the devices, again, match up perfectly with the 3D model and are completely functional with the PLC code as they are. And just to give an idea, the scaling up of this is a quick overview going from a small size to the large size of the scale of the project that can be easily replicated inside the software. You know, this was a slightly tweaked system of a material handling delivery that we provided to an end user. And we were able to model the entire system in the, using the software. I believe this was in the neighborhood of 800 conveyor elements, approximately 80 merges, and 70 diverts that are all being simulated and verified directly with the production PLC code that we can then use to emulate, do virtual commissioning, and ensure a smooth delivery of the product. And that's pretty much where we're at. Sean, anything else you want to add?
No.
Well, then
That's good. If there's any questions,
yeah, kick it over if there happen to be any questions to be answered.
Or come see us at our booth, just on the other side of the aisle there. All right. Thank you.
All right. Thanks.
How quickly?
as soon as I'm done. Yes. So green is go. That'll advance them. Yep. You'll turn on the slides as soon as I'm done. This is going backwards. This is laser pointer. Not necessary. Forward, backward. That's all it's doing. All right. Good afternoon, Hanover. We are all set for our next presentation from Metropolitan Technologies. I would like to introduce you to Daley Brown, the co-founder and CEO of Metropolitan Technologies, all the way from Ottawa, Canada, the capital of our illustrious country. Over to you, Daley.
All right, thanks for that introduction. So good afternoon, or I guess, yeah, good afternoon, everybody. I'm here to talk to you about secure by design and default smart infrastructure, the tools and techniques that we use to accomplish that, and what exactly that means. And so to start, I'll give you a bit of a background of my company and why we came about to believe in this type of technologies. So when we first started Metropolitan, we started as a smart cities company, and we were looking to build artificial intelligence derived applications for traffic optimization and other city applications. And so the problem we were trying to solve is equity within a city. And so when we were looking for a platform to build our applications on top of, we were looking for something that had the privacy and security guarantees that we thought were appropriate for public infrastructure. What we found was most available platforms on the market didn't have the privacy, security, and reliability concerns we had. Part of that is because, and I'll get to this in a bit, is the background of me and my co-founder, where we come from a defense and aerospace background, where security and resilience is paramount. So when we started as a city company, we ended up broadening our perspective to be a critical infrastructure company. And we decided to focus on security and resiliency. And so our updated vision and the reason our company exists now is to be the secure digital backbone of the world's critical infrastructure. And these are some of the segments in which we operate in: energy and utilities, city, transportation, mining, industry 4.0, and defense and security. Types of segments that affect our day-to-day lives where we think we can make a difference. And so just some evidence to suggest that the problem we're trying to solve is a big problem. The digital transformation of industry has brought about a lot of benefits, but also as things digitize and become connected over the internet, there's been more cybersecurity vulnerabilities, both exploited and discovered. And the cost of these vulnerabilities is increasing year over year. So just in one of the latest surveys, it quadrupled in the energy and water utilities sector for a single cybersecurity incident to recover from it, and that's from a Sophos survey. Other surveys have this increasing hundreds of percentages each year in terms of cybersecurity attacks, or at least attempted attacks at operational technologies and critical infrastructure. So the need for a new approach is required than what we do today, and that's where the secure by design and default smart infrastructure comes into play. And so a bit about myself. My background's in defense and aerospace. I'm an ex-General Dynamics person. My co-founder, also defense and aerospace, also ex-General Dynamics. I worked there for many years, over 14 years, maybe 15 years, something like that. My co-founder was there for quite a long time. We worked very closely together building helicopters, airplanes, and other military technologies, including battlefield networks. And we wanted to take a lot of the approaches we made to those systems and put them in a commercial product where we think we can make a difference. And so just for a bit of situational awareness, when we started our smart infrastructure company and what we build now, we kind of live in this area. So this is a McKinsey diagram, but basically we build the applications and the connectivity technology to enable these types of smart infrastructures and smart applications. And we build it with a secure by design and default principle with a focus on connectivity, cybersecurity, and resilience. So like I was mentioning, when we were looking for a platform to build our product on and we didn't find what we were looking for, these were the two types of technology, there are two types of things we were interested in, was the resilience that we would find in battlefield networks and the safety and security you'd find in aerospace and flight control systems. And so when we couldn't find what we were looking for, we decided to build our own with these two interrelated types of technologies: resilience, safety, security, built from the ground up, and using the same technologies that we built in the aerospace applications and the defense tactical networks that we had previously deployed in our previous job. And so the product we actually built is a decentralized IoT connectivity and OT cybersecurity platform to increase the resilience of the operational technology networks that underpin our critical infrastructure. And we do it in a slightly different way. So we build a peer-to-peer decentralized network. At the edge, we build software to connect sensors and other devices using formally verified software to prove the absence of runtime errors and to prove key security and safety properties of our system under a certain set of assumptions. And so that type of technology, formal verification, is actually used quite frequently in flight control systems. So the commercial aerospace and other avionics that we rely on every day use these technologies to mathematically model and prove certain properties, either safety or security. And that provides a lot of high assurance that these products are going to work like they intend to do. For a long time, this type of technology was very expensive and difficult to deploy and took many decades of research and iterations. But we feel it's a good time to start to bring those technologies into more commercial offerings because the tools and techniques and the infrastructure to support this type of development has become a lot easier and cheaper, and the barrier to entry is a lot smaller. And so formal verification and formal methods is one of the key underlying tools that we use to prove or to develop secure by design and default infrastructure. Secondly, is our platform protects data in motion using 2 layers of encryption. We use an outer mesh network layer that overlays unsecured and untrusted networks and an inner peer-to-peer layer that provides data-centric security. So it provides fine access and integrity at the data topic level. These are also techniques that we brought from the defense world. So the 2 layers of encryption provides a defense in-depth mechanism to protect both outsider threats to your network and to insider threats to your critical infrastructure networks, which is increasingly becoming a more concern with big, large infrastructure operators. The reason why we do data-centric security as well on the inner layer is so that you can provide fine-grained access control to operationally relevant and sensitive data, and so that only people, or not just people, but devices and applications have a need-to-know access to this type of data. It also reinforces the integrity of data such that it cannot be manipulated and the provenance of the data is guaranteed to be known, which is especially important for controlling and monitoring high sensitive and high safety critical infrastructure systems like a power grid. And finally, we have a peer-to-peer network where we direct data to devices and applications on a need-to-know basis. This is different than a lot of centralized infrastructures that might use converged clouds to both broker data and manage it. Ours is completely decentralized, which eliminates single points of failure in your operational technology networks and allows for redundancy and resilience in the network in case single nodes go down. We can reroute data to ensure it gets delivered into the destination that it's supposed to. So there's 2 ways that we developed our platform to get onto it. For greenfield developments, or blue ocean, whatever you want to call it, for brand new people developing distributed control systems, critical infrastructure deployments, we provide a software development kit that's secure by design, available in different programming languages, but uses a lot of the techniques that I had talked about to get data, devices, and applications onto the network. And for existing networks that you want to enrich and harmonize the security and privacy and provide some resiliency to the connectivity, we're developing an IoT gateway for extremely rugged deployments that provides ubiquitous connectivity, so both terrestrial and using satellite-based 5G networks, to give you connectivity anywhere in the world. And all that basically is a ruggedized hardware with our software development kit encapsulated into an application, and it provides you the same guarantees as we just talked about with the software development kit that we're developing. And in terms of actually what this looks like in a real deployment, for example, in industrial control systems, there is a few different integration options, each increasingly more disruptive to the actual deployment, but also each increasingly more secure. And so at the left side, the good approach is to provide site-to-site connectivity, where we might have our edge gateway sitting in front of an existing operational technology network, like a substation. And so it can provide data aggregation at the substation level, as one example, and everything beyond that to the control systems in a control center somewhere else in the world or somewhere else not geographically located. We provide all the type of resilience, security, and safety guarantees that we talked about before. However, there's a lot of implicit trust in the network still. Everything that connects into our gateway still has implicit trust because that data itself is not managed by our system. Secondly, you can attach our gateway inline to each device in your existing network to provide separate connectivity. Now, obviously, this is quite a bit more integrated or disruptive because there's going to be a proliferation of a lot of edge devices into your existing systems. However, this provides a lot of explicit zero trust because each gateway itself is now managed, or each component or asset in your system now has its own management gateway, which ensures that the data-centric encryption and all the other kind of features and techniques we talked about are applicable at that single device asset level. And finally, we provide the software development kit for what I was talking about, like blue ocean or greenfield developments, where you can use our actual software to build your distributed control systems or your critical infrastructure deployments on top of. And this provides the most trust, security, and privacy in the network, because it's actually at the actual application level where we're doing all the data-centric and all the different types of security and safety approaches that we were talking about. So that's zero trust, data-centric security at the application level versus at the device level versus at the site level. So I kind of alluded to this earlier in a couple slides ago about the different security features that we provide, but just to reiterate, so we have an outer mesh network layer that overlays untrusted and unsecured networks. Historically, there was a lot of trust in existing network infrastructure, and a lot of security techniques were about securing the actual network itself. We make it so that we don't necessarily have to trust the network that you're using, and because we are going to overlay with our own virtual network that's secure by design. Inside of that, like I talked about earlier, is the peer-to-peer network. So it's a separate, independently encrypted zero-trust network as well for software that provides the peer-to-peer technology that we already talked about. The other couple interesting thing is the access control. So we, at each individual node, instead of centrally controlling and enforcing access policies, our software and edge device will do that at the actual node. So it's a distributed system, and it does that there. And finally, we do cryptographic signatures. So I was talking about data integrity, especially important in critical infrastructure deployments. Everything in our system that uses our software development kit, all data is signed cryptographically, so you know the provenance, you know the integrity can be trusted of the data. And finally, the ability to deploy apps, our own or third-party apps using our software development kit, allows you to deploy apps anywhere in the world to get access to data in our mesh network in a very secure way without compromising the security of the system or the safety of it. And finally, because we come from an aerospace background, we're very sensitive to functional safety and regulations. And so from the ground up, our software development kit, our whole platform, and the edge technologies has been built for cybersecurity, functional safety, and interoperability for the types of regulations you would expect to find in highly safe and sensitive environments for control systems, power, electricity, defense, and otherwise. So just to talk about the progress we've made to date. So we have 2 ongoing pilots. We're a pre-commercial company, but we're in the piloting phase. So our first pilot is an industrial security pilot. We're working with a couple of great companies, Thales, a French multinational, a world leader in security, Quantum Bridge, which is actually another Canadian startup showcasing here at Hannover Messe. They build quantum-safe communication technologies. University of Toronto, a well-known research university, one of the top in the world in many areas, including industrial security. And finally, Digital, which is Canada's Supercluster Fund, which is a sibling organization to NGen, is providing the funding for this pilot project. And we're providing quantum-safe security and zero-trust data-centric security to industrial control systems that are the backbone of our critical infrastructure. And so this is a 2-year pilot project. We just kicked it off this January. First in a simulation environment, and then we're going to be deploying it at Thales' newly opened Center of Excellence for Industrial Security in Fredericton, New Brunswick, in Canada. And just taking a step back, where you can see where the applications of this is going, is if you look at the energy and utilities space, we're increasingly going to a distributed energy architecture where you have distributed energy resources, grid storage, renewable energy is coming online, and the need for secure information sharing to coordinate between all these distributed systems and to ensure the security and integrity of that data so that it functions correctly is paramount. And so this is kind of the broad, bigger picture is what you're working for, is what this type of secure information sharing distributed architectures can enable in the future. And it's not a limit, it's not just the energy and utilities sector alone, but these distributed control systems, these distributed architectures and deployments are applicable to both cities, mining, it's been in the military forever, that's the heritage of it, and other use cases that you can think of. And so just to kind of summarize kind of the points we talked about, so the secure by design and default approach, using zero trust security models with memory safe programming languages and software development, and formal methods to prove the absence of runtime errors and key integrity properties of your system are all techniques that are emerging to help make the more safe and secure infrastructure. Private data-centric encryption ensures that everything is accessed on a need-to-know basis and the integrity of the data is preserved. Our platform removes data silos. It's distributed and decentralized for a more resilient infrastructure and to eliminate single points of failure in networks. And finally, it democratizes data because we can provide access to all data in the network without compromising security and safety of the system. And just some values of our company is we prioritize privacy, security, safety, equity, and reliability. And that's it. Thank you.
Great job. Really interesting. So,
December 26th. Yeah, right now it's simulated, and we're going to go to Totalis as a center of excellence for industrial security. They just opened it in February, so last month. So we're going to deploy everything there with hardware in the loop simulation, so we simulate industrial control.
shoot, so
Yeah.
I'll
So
give you
wrap
the,
up a little bit before that.
yeah, I'll give you the 5 minute warning just before the wrap, just so you know what's coming.
Sounds good.
Okay. All right, we are ready to go with the next presentation. Today, this is a presentation from EdgeCom Energy, and with us today is Tanner Behrend from the VP Strategic Growth, coming to us all the way from Calgary, Alberta. So I'll turn it over to you, Tanner.
Awesome. Thank you very much. Lovely to see everyone here today. So as I was just introduced, I'm Tanner Behrend from EdgeCom Energy. Just going to give a quick session here talking about how we've been able to use AI co-pilots to enable manufacturing excellence, specifically looking at real-time optimization and sustainability. So again, lovely to meet you all. Tanner Behrend from EdgeCom Energy. At the highest level possible, we're an IoT and AI energy management firm. So we're based in Toronto. Generally speaking, our goal is to work with large energy consumers to help them reduce their costs, reduce their emissions, and reduce their downtime. So we're currently deployed in 190 facilities across North America. And again, you can see from some of the logos I've highlighted here on the top, it's some of your more recognizable names across, again, those industrial, manufacturing, and some large commercial facilities as well. But hopping right into it, as you all well know, the energy transition is here. It's well upon us. Obviously, as a result of that, we're seeing the grid regulations and pricing structures are undergoing very rapid changes and are, generally speaking, becoming more complicated and volatile. So obviously, for some facilities, this is a massive potential pitfall, but it also opens up significant opportunities for facilities that are able to take advantage of these new systems and new pricing structures. So despite the fact that energy is often a very large input cost for some of these industrial facilities, we tend to find that most facilities are stuck in the past. I can, broadly speaking, lump folks into 2 buckets here. On the left side of the screen here, we work with a significant amount of facilities who, before leveraging our services, our technology, our offerings, their only energy data comes in the form of a monthly bill. So again, aggregated across the month, hidden behind tariffs that no one knows how to understand. You're not really getting any insights out of this information. On the other side of the screen here, we work with some more sophisticated energy consumers. They've invested hundreds of thousands or millions of dollars into very sophisticated SCADA or DCS systems. As you can see, this is from one of our customers, actually. The interfaces that you're looking at are antiquated. They're pulled right out of 1980, and you're really not getting the most bang for your buck. You're lucky if you have 1 or 2 people on your staff that can actually use that system to its full capabilities. So you're really leaving a lot of opportunities on the table. And oftentimes, these systems are very internally focused. So there's no information in terms of what's happening on the grid. So it's very hard to, again, take data from separate platforms, synthesize them, and make decisions in real time. So as a result, again, whether you fall into the energy bucket or the SCADA bucket, these facilities, large facilities in general, whether that's commercial or industrial, waste on average 12 to 20% on energy every single month. So obviously, not only are you wasting money, you're also emitting more CO2 than is otherwise required. So to act on that potential opportunity, these facilities, they need a solution that makes it as easy as possible for them to gather that energy data, analyze that data in real time, and then take control or change their operations based off that analysis. I think one of the key things here, especially with the volatility that we're seeing, bringing all of those 3 kind of categories as close to real time as possible is paramount, so you can act on these opportunities as they become available. So one of the kind of the key focuses here is, again, data, and more data. Effectively, there's kind of 4 different levels to this. So issue level, or the kind of level 1 issue that we're dealing with is a lot of these facilities lack granular data, period. So again, they have a monthly bill, maybe they have interval data. Oftentimes, that visibility doesn't go very far downstream. So again, the opportunities you're able to identify at a very high level are very limited. If you take that to the next step, we do have some facilities who, again, they've done audits, they've done walkthroughs, they've started to collect some of this data, but it's very manual. So it's very tedious, it's time consuming. There's obviously the chance of there being human errors, especially when you're talking about audits. That audit could happen on the best day for your facility or the worst day ever. So you might be skewed in terms of what happened on that individual day, and you're not getting enough data to actually make accurate representations of what's happening. Once you do have more data, then you have too much data. So sometimes, again, when you're talking about, as you'll see on the next slide, hundreds of data points coming at you in near real time, all of a sudden it becomes very complicated and very time consuming to do that data analysis, and you're removing yourself even further from, again, making those real-time optimization decisions. So I mentioned this previously, but just talking about some of that data that an industrial or large commercial facility needs to leverage. Obviously, again, we have facility data. So, real-time energy insets that could hypothetically be down to the machine level. So again, you can be on a very granular time frame, getting second-by-second information on every asset within your facility. You then need to baseline this information and correlate it to whatever's driving costs within your facility. So whether that's production, occupancy, weather, again, it might be some combination of all three, but you have to do that on a process-by-process basis. Talking about weather, obviously, again, you have to understand what's happening weather-wise, heating and cooling days, all that fun stuff. Billing data and all the complexities. Again, if you're talking about all three utilities, minimum, you're looking at 3 different bills. Some folks have their electric bills also split up across multiple different providers, so even further complexities to manage there. The funnest part, real-time grid data. So again, different across different markets, but you're talking about dozens, maybe even hundreds of points that need to be scraped in real time to actually understand what's happening within some of these markets. So you can already see just across these 4 categories, the amount of data that one could hypothetically be looking at on a day-to-day and hour-to-hour basis is absolutely massive. And that's even just within a single facility. So imagine, hey, I'm operating 12 facilities across 6 countries. You've just multiplied that and made this incredibly more complicated. And again, you're removing yourself further and further from that real-time decision making. So this might be a little bit too much of a basic slide here, but just a quick TED Talk here on Gen AI. Comparing this to traditional AI, your traditional AI is really more focused on the data processing and predictions, whereas again, generative AI is generative in nature, so you're creating net new content. One of the most popular types of generative AI is obviously LLMs, ChatGPT and the ilk. And again, the big focus there is that it's AI that can generate content and understands human language. So again, one of the kind of the 2 big benefits here to stress, especially within the world of energy, one, again, enables us to do more of that processing, bring that analysis closer to real time. But the other big kind of benefit here is it also enables non-technical people to interact with technical models and get the data that they're looking for. So we'll talk about that a little bit further, but talking broadly about the benefits that we see, I'd lump them into those buckets. So specifically when we're talking about LLM use cases as it relates to energy, again, large energy consumers, there's a bunch of different use cases that we could start to support. And again, a lot of these are interconnected or related in some capacity. So when you're talking about energy forecasting, that is a direct connection to what we're doing in terms of grid management or program participation. Production optimization, again, large driver of cost, taking advantage of what's happening on the grid and taking advantage of energy forecasting. You can build kind of clockwise around this and start to take more and more advantage of these AI copilots depending on what your specific use cases and what your priority are within your facility. So again, emissions reporting, load scheduling, eventually getting to the point where you're actually enabling and tracking the carbon emission reductions on top of this as well. All of these can be further enabled by the use of LLMs and Gen AI within these manufacturing and other energy-intensive settings. So talking a little bit more kind of poignantly about what some of those benefits could look like within a facility, I'll talk about these a little bit more in depth in the coming slides, but real-time production optimization, improving equipment reliability, making smarter decisions, especially across teams, and then driving sustainability on multiple different fronts. So talking about the first point that we showed there, again, specifically when you're talking about production, obviously every facility wants to optimize the production as much as possible, and it's never going to be an option to just, I'm going to cut production in half. You always need to prioritize hitting that production goal on whatever basis you're looking at. So again, prioritizing the fact that analyzing data from various sources in real time is very hard. And then also having a knowledge of those constraints requires some level of human interaction. So a co-pilot in this use case, again, process all that information, both internal and external, so what's happening within the facility as well as what's happening on the grid, weather-wise, et cetera, but then also being able to leverage the operator's knowledge in terms of what is and is not possible within that facility. So there's a quick example that's going to pop up on the screen here. Effectively, so this is our AI co-pilot that's already deployed in 190 facilities. The use case, a customer here is asking for a production schedule for the next 24 hours. So they'll input what that production goal is. They're actually changing from their baseline manufacturing amount from 200 kilograms, they're bumping that up to 250. And what the co-pilot will do is we'll give you an hour-by-hour breakdown of exactly how hard you should run all of the loads within your facility. So again, you can see you've got a whole bunch of different shiftable or non-shiftable loads that are being covered here. And effectively, this co-pilot can learn from the priorities, the constraints within your facility, and can make adjustments on the fly. So hypothetically, a user could then come in and say, manufacturing line 2 is down for maintenance for an hour and a half. Rejig my schedule, I still need to produce that same output, and all the EVs need to be at 85% by the end of the day. So managing those dynamically, and again, hitting that outcome without jeopardizing the production goals that this facility has. So looking at the equipment reliability, the predictive maintenance side of things, again, because the AI can effectively serve as 24/7 oversight on all of these assets and do that constant, not only monitoring, but also calculations in terms of how is this asset performing compared to last week, last month, its normal threshold. There's a lot of, again, efficiencies that we can help garner just by being that second set of eyes, so you don't have to be manually monitoring some of these assets. So again, creating that safety net so that things are caught before they go wrong. Obviously, we're also getting into some of those more data-driven retrofits that can also lead into more of a decarbonization lens as well. But really enabling that data to be more accessible so you can really use it to empower your decisions. Which leads us right into this next point here. Again, I think one of the benefits that we highlighted on one of the previous slides here was, again, using Copilot so non-technical teams can interact with very technical topics. So hypothetically here, your finance team, if they see that their bill is 12% higher, you can ask a Copilot directly what was driving those costs over the last month. You don't have to then go talk to your operations team, investigate with the folks on the floor. This can be answered in a matter of seconds. So, hey, yes, our costs were up 12%, but our production was up 13.5%. So we're actually doing great, and we've separated ourselves from the baseline. Just some examples of, again, how these copilots can be used to speed up and create additional efficiencies, especially when it comes to cross-collaboration. So again, enabling data to be shared more effectively from the source between maintenance, operation, finance, sales, anyone who that data is relevant to. It's available at their fingertips, and you're making it as easy as possible for folks to comprehend what's happening. So a couple other decisions here. Again, these are very related to the lovely world of energy management, but equipment retrofits, you're obviously going to have multiple stakeholders sharing that efficiently. Load shifting or participating in other programs that involve curtailment or price avoidance. And again, predictive maintenance. So multiple stakeholders and using this really as a source of truth for any topic that touches energy. So again, driving sustainability, everything that I just listed previously has some sort of impact on your sustainability overall. But talking about kind of some of the more poignant points here. So identifying production inefficiencies, a lot of customers now, it's even just identifying their baseline. So here's what my cost and amount of electricity per widget and the resulting emissions per widget looks like now. Here's the goal that I'm trying to get to. Let's make sure we're not backsliding. Let's make sure, again, that this data is being shared across all the teams that have some sort of stake or some sort of say in this specific project. Again, anything that you're doing from a retrofit perspective, the cleanest kilowatt is the one you don't have to produce. So if we can identify those inefficiencies, act on them, whether it's low cost or no cost, or something more capitally intensive, using this again to identify where those priorities should and should not be, and identify which projects align with the company's priorities and make sense financially. So this is actually one of the, again, the 190 facilities that's currently using our Copilot. So this is a office parts manufacturer in Ontario, Canada. Just talking about, again, kind of some of the high-level benefits here. They generated almost 100K in the first year of using effectively our full package of solutions. So leveraging what we're able to do using traditional AI on our grid forecasts, as well as using the AI Copilot to actually make suggestions to how they're running their facility to respond to different opportunities that exist on the grid. So again, there's some high-level stats that are kind of listed here. Big one to focus on, almost $100,000 in first-year savings, and they identified that within the first 2 weeks of using our platform. So where can we take this next? I think one thing that we're going to see effectively with the launching of more AI agents is you're going to have more communication between those AI agents, so decisions can be made without humans being as involved. So, hypothetically, you have a maintenance copilot. We can interact directly with that maintenance copilot and help schedule predictive maintenance or maintenance just on a better time frame based off the analytics and the data that we're able to see on our end. The next level of this, and I think, again, a little bit trickier within some of these manufacturing settings, but once they're more comfortable with having AI copilots make these recommendations that make sense and actually provide significant benefit, the next level of that is letting these copilots actually take control. So there's two kind of categories that I'll lump this into. Effectively, there's your non-critical downstream assets is, I think, a logical starting point. Your HVAC systems, your non-critical motors, compressors that are associated with, again, your auxiliary processes. The other level of that is any sort of DER that you have on site. So you can lump some of those HVAC units, rooftop units, building automation systems into that same bucket, but also looking at things like generators, batteries. Again, eventually, could we use AI co-pilots to entirely run a facility? Absolutely. I think most manufacturers will be very hesitant to give over the keys, especially when, again, their goal is always going to be produce the highest quality goods on target and on time. So there's going to be levels to it, but I think there's kind of a hierarchy that we can potentially follow here. So talked a lot about the AI Copilot that, again, we're spending a lot of time developing. We have a lot of facilities that are using this and getting benefits on a day-to-day basis. But really the whole point of the EdgeCom energy ecosystem is to be that connecting piece between what's happening within the facility and what's happening on the grid. So the Copilot is a central piece of that. But just speaking at a high level, via data track, we can give you real-time consumption information across every asset, every process, every machine, show you exactly what that's consuming in real time and how that's costing you. On the P-track side of things, it's effectively everything grid interactivity. So we're not only scraping your energy rates, but we're forecasting the dynamic elements of your bill, showing you line item by line item what process is really driving that cost within your facility. Again, anything voluntary or mandatory program-wise, we'll streamline that as much as possible and help you identify which loads and processes are relevant within your facility to participate in that specific opportunity, given your cost of curtailment, your constraints, and really what your facility is looking to do. Final product here at the bottom is NeuroCharge. So if you have a DER of any capacity, we can remotely dispatch and optimize those assets, again, considering what's happening within the facility as well as what's happening on the grid. So delivering massive value to whoever's owning that asset, but not having them involved in the day-to-day operation of that individual asset. Again, whether it's a battery, generator, building automation system, rooftop unit, we can tap into a whole bunch of things. So again, we talked a lot about LLMs. This kind of quickly just talks about what I was talking about. So again, on the peak and price prediction side of things, that's a prime example of where we use traditional AI. There's generative AI kind of throughput that we can start to now garner and act on now that we have more experience. DR optimization, massively growing category, and we're becoming more integrated in a lot of these industrial sites that do have multiple types of DERs that need to be coordinated in conjunction with their actual loads. Again, insights and recommendations, that's really what we're doing, providing bespoke recommendations empowered by data on as close to real time as possible to help these facilities reduce their costs, reduce their emissions, and reduce their downtime. So just kind of some recent highlights that I wanted to quickly talk about here. Microsoft and ABB ran a global industrial AI challenge. EdgeCom won that. So we have a partnership with ABB now, and we're going to be rolling this out across thousands of facilities across Europe in the coming months and years. Similarly, we won Shell's New Energy Challenge in November of last year. So this solution is also going to be pushed forward to pilot in some Shell sites. And again, we've got some of the other folks that we're actively collaborating with highlighted on the screen as well. So on that note, thank you very much for your time. It was great to see you all. That was all between since May 2020. So something particular in terms of product change or just the traction change? It was, so the AI element that we had pushed forward, we've only had that Copilot since
All right. We're ready to get started with the next presentation. This presentation is from Global DWS, based out of Toronto, Ontario. I have the pleasure to say that we funded a project with Global DWS, who rose to the challenge during COVID to develop a disinfecting robot. So thanks, guys. Today we have Rami Webb, CEO, and we have Yahya Saad, the co-founder and chief digital officer. Gentlemen.
Thank you, Robert. First, as Robert mentioned, my name is Ram Wahbi. I'm the co-founder and chief digital officer, and I have here Yahya Saad. Today, we will talk about Verbrix. It's an AI-enabled robotics platform for smart manufacturing. Our main objective is how to make factories more efficient, more sustainable, using robotics and AI and IoT. So today, So we will go through the market needs, why we are doing that, what are the main business objectives, and then we will give you brief introductions about the global DWS, and then we go about all the portfolios and services and products that we have. And then we will dig deeper about the Verbrix, which is a virtual bricks, and the main capability of the platform. After that, we will focus on the return on investment, how people will be able to capitalize on the main objective of the solutions. So before we start, when we talk about smart manufacturing and why now, as we know in the Industry Revolution 4.0, data is the new oil. Data is the blood of all the manufacturing capabilities. So to be able to improve our process and automation, we need the data that is the core foundation of all the data processing. So based on the statistics, they found that 82% of manufacturing organizations, they face unplanned downtime that costs more than $50 billion in their operations, which is massive from operation perspective. And they found that 70% of those manufacturing organizations, they are using predictive maintenance to be able to make their operation more efficient and to make their assets life cycle is longer, which will reduce also the cost by 40%. In addition to the operations, they found that 30 to 35 to 50% of organizations, they were able to use real-time AI-enabled analytics to be able to reduce the number of incidents in their workplaces. With all of that, they still need data to be able to do all of those changes in their workplaces. In addition, the final one, we need to make our environment more compliant to the regulation and standards. So they found that 85% of organizations, they need data to be more sustainable, especially with the demand for net zero in the organization. With all those business factors and areas, we need data, we need cognitive automation, we need Internet of Things to be able to simplify the data acquisition, to be able to do all those changes on the organization. So based on that, Global DWS is a Toronto-based system integrator and solution provider focused on robotics, AI, and IoT. Global DWS stands for Global Digital Workplace Services. Our main objective is to make our workplaces using AI and IoT plus robotics to make it more productive, more sustainable, and more human-centric, how to increase satisfaction of customers and employees using all those technical capabilities. To be able to do that, Global DWS was able to build a group of factors and solutions and the new capabilities, starting from social robot that has the voice interaction, computer vision, and autonomous navigation that can help to be in the front end of any manufacturing or many workplaces. In addition, we built a complete Verbrix, which is our main topic for today, which is able to do a complete inspection and analytic for workplaces to make our workplaces more efficient. In addition, to support the back-end optimization, we have a disinfection service robot, which will be able also to make our environment more compliant to the health and safety requirement like WAL. all of those, like in the global DWS, we try not to build silos of technology. We build them in a fully integrated smart manufacturing ecosystem, where we make sure all those technologies are able to work together in a fully harmonized approaches. Because the main challenge in the current market is the silos of technologies and AI and data analytics that we have. So as you see, global DWS will not just push technology or enable just the new robotics. We are trying to build a solution that will address the market need in a fully integrated end-to-end. And all of those are integrated with the smart building and smart manufacturing back-end system, where you are able to use AI and data analytics on all the data you are collecting in the back end. With all of that, so today we will focus in our presentation with this portfolio on the Verbrix, that Yahya Saad will be able to give you a brief introduction about what are the main capability of Verbrix. Okay?
Thank you, Rami. So, as Rami mentioned, one of the flagship products that we're presenting today is Verbrix. Verbrix stands for Virtual Bricks, and it's our digital twin solution that we've developed to enhance and analyze and inspect health and safety, occupancy, and sustainability in workplaces. And these workplaces vary. So there's smart manufacturing, there's industrial facilities. We have also an example that we will show in a minute on warehouses. So there's different deployments for smart manufacturing. And the main purpose of Verbrix is to help enhance, to collect data and analyze for health and safety. This is one example that I'm showing over here. This is Verbrix in a warehouse, and we will see a short video after this slide that will show the robot in action. The robot, as you can see here, aided with several stationary units that are positioned on many of the different locations within the warehouse. We're able to collect health and safety, environmental scanning data. So this varies from temperature, humidity, air quality, different type of indoor gases like CO, CO2, NO2, radon, and ozone gases, in addition to light and noise levels, which all affect storage, it affects warehouses and efficiency of manufacturing. What we can see here is more than 20 sensors in the globe on top of the robot, aided with a 360 camera on top. The 360 camera assists in collecting occupancy metrics. So the 360 camera is taking images. We have the full body blurred for privacy. And the camera is counting the number of people in a space. It's counting the number of available chairs or whatnot, in addition to our proprietary AI model, computer vision, that is running on the robot that does safety data collection. So we have here the camera taking images for like water spills, if there's any obstacles at the emergency exits. All these are hazards within a workplace, within a smart manufacturing facility that need to be collected and dealt with. All this information is then relayed back to our cloud environment, which is based on Microsoft Azure, secured and end-to-end encrypted. The robot moves around the space autonomously, runs by itself. Different locations that have been predefined, it goes and inspects the data and collects it, in addition to the built-in internet connectivity for these devices. So there's no need to integrate with any local infrastructure, whether it's a Wi-Fi, whether it's any of your local resources that need to be connected, because as we know, there's many complexities there. This runs autonomously and runs through the space without needing to integrate. The last thing I wanted to mention is the robot is equipped with many AI capabilities that vary from localization to SLAM and AI, computer vision, and data analytics dashboard that helps you analyze through the space. This is the robot in action. This is showing you the Verbrix solution running in a last mile facility. We were able to help, and I'll talk about this in a minute in the next slide, to help them with managing and being able to collect data from the space and being able to analyze it. As we can see here, this is sample of the dashboards that are produced from the system. So there's predefined dashboards for the data that's being collected, then analyzed, in addition to 360 images that are stitched together to create a 3D model of your space. So this is another digital twin representation of your space and also showing you the changes that are happening in your space, in addition to being able to report on this. The dashboard is also equipped with an AI-driven analytics. So there's generative AI solution that's running on the dashboard that helps you analyze the data that you're bringing in. So we collect the data, we analyze it, and now you're also able to make sense of this data based on what's running in the dashboard. The return on investment. So I wanted to mention one of the case studies that we ran. This is for the last mile delivery facility based in North York. They were able to save on almost $120,000 investment that was avoided due to the inspection that was implemented. So they were able to prove that their facility is healthy, safe, and there's no need to add any special requirements for the HVAC system or for special doors that need to open whenever nitrogen oxide levels are high. And that's due to the cars and trucks going inside and dropping off packages and then picking them up. So there's fumes inside the space. What I want to mention is the return on investment doesn't stop at health and safety. There's many different return on investments that can be realized from this implementing the similar solutions and the Verbex in specific. Safety and compliance, reduce in downtime, energy cost savings, sustainability gains, and smart asset utilization. As we can see, the savings range from between 30 to 50% fewer incidents with respect to safety, avoiding many insurance costs and additional downtime, in addition to reduced downtime with up to 40% saving between $500,000 up to $1 million in typical facilities, energy cost savings with a reduction of at least 15 to 25% based on the implementation of the solution, in addition to sustainability gains with potential tax incentives that range from $50,000 to $20,000 in savings and tax incentives. And last, with the increased utilization of the space, which varies from 10 to 20% based on the robot collecting this data and analyzing it from your space. So that's all from my side. I don't know if you had any questions. We're here to answer them.
Yeah.
Yeah, we're over here, so please come by. This was just a teaser, so there's a lot of information that we can show you that we're more than welcome to present to you. Okay?
Thank you.
Thank you.
Yes.
All right, good afternoon, Hanover. We are ready to go with the next presentation. This presentation comes all the way from the beautiful west coast of Canada, Vancouver, BC. Presenting is a TP7 Red Crow College AI and Robotics Research Corporation with Hadley Fox, CTO and founder. Over to you, Hadley.
All right. Thank you, guys. I'm really excited to be here and really appreciate the opportunity Government of Canada and NGen brought us here to give us a platform to showcase the most forefront AI technologies. So at first I want to talk about, so what happened here was at GTC 2025, you guys can see there's like a trend. At the beginning of 2012, we had AlexNet, the first time deep learning getting into everyone's vision to be performing way better than traditional machine learnings. And the next step, we had speech recognitions and medical imagings and pattern recognitions. These machine learnings really advancing all of the different fields and in AI applications. And then 2022, we know that ChatGPT moment took place. So with ChatGPT moments, we saw what deep learning could really do with predicting the next words and advancing intelligence. And then so started from 2023, 2024, Jensen Huang said there was like agentic AI has been around to advance AI even further with hallucination correction or even tool and searching functions. I added like a COT means chain of thought. You guys probably know ChatGPT O1 models. Chain of thought's really helping reducing the hallucination rates by pretty much a lot more. And then he predicted the next step would be physical AI. The physical AI is going to be incorporating agentic AI, chain of thought, and everything prior. So it's going to be the future. And just quickly, I want to know my audience. Any of you are not a robot? Please raise your hand. Good. So I know you guys are not a robot in disguise, so can start to talk bad things about them and the good part. Yeah. So today's agenda, we're going to talk about AI and robotics landscapes and what physical spatial AI is and the AI and robotic control history. And then we're going to talk about our company, what we're doing, and what our next step is, and our approaches and the challenges ahead, and how we're coping with them, and our future directions and potential collaborations. So I want to talk about first of all, it's like AI and robotics is they're not convergent. So we don't have the magic bullet. We don't have the one solution to trump them all to finishing completely do an open-end AI robotic control. So right now, so many companies are exploring so many different options. There are diffusion models, transformer models, and lately there are a lot of people using Memba models. And there are, of course, hybrid models. And then traditionally, we're using a lot more reinforcement learning for robotics policies. So what do you think, guys, think is the best model there is? I personally believe that hybrid model is the best options. Because all these models, they are essentially, except for reinforcement learning, they are essentially all deep learnings. So they all have their pros and cons. And then, of course, I believe there's a huge market for AI control robotics compared to traditional hard-coded robotics. So they can actually come from industrial use only to actual commercial use, and even eventually, when the cost goes down, to consumer usage. So let's talk about what actually is physical spatial AI. So there are three key elements. So space, time, and fundamental physics. We can go with space. I brought two props today to showcase what actual spatial AI is, so it doesn't confuse everyone just with words. So imagine, also the doorbell is actually from my bedroom. So we have like the round door, the doorknob, the round doorknob and the elongated doorknobs, right? Imagine yourself as a robot. You are only with one gripper. So you don't have changing tools, you don't have fixed routes. So when you're approaching, you have the inference, as an AI model, you have the inference. Oh, that's a doorknob, but it's the round one. So with your gripper or your deck's arms, you're gonna approach them maybe potentially grabbing them like this. But when you're approaching them with elongated doorknobs, you probably wanna approach them like this instead. So that's what spatial AI is about. So you identify the object, you calculate the relationship between the object and how you're going to approach the object. So this part is the spatial AI in simple terms. And the next part I want to talk about time. So time is in robotics and AI inferencing is more about temporal computing. So I got a little example here. It's like you see a skateboarder. So a lot of like ChatGPT or regular traditional AIs, they predict the next words, or like they'll see one photo tell you what it is. But when we are in motion, you see like this. Pretend you are in a robot. You're sitting at the end of this slope, and then you see a skateboarder is heading towards you. You can't just inference one frame. You can't be like, oh, there's a skateboarder is coming. But you have to inference, he's approaching me, I have to get out of the way for safety reasons. So that way, that's temporal computing. So it has to be incorporated in our physical spatial AI. So that's basically what spatial and time is about. And the next part is about, it's about fundamental physics. That part is actually a lot simpler. So when you see, like, for example, when you're going to, you're a robot, you're patrolling a ground. You see it's raining. You know, it's going to be slippery. I'm probably going to go a little bit slower, or it's icy, or it's just really dry. So these fundamental physics properties going to determine your robot's inference and decisions. So these three elements are the most important things for physical spatial AI. So I want to now talk about classical control and AI-based control. So classical AI control, we have like, you guys know, like rule-based, if distance is smaller than x, then stop. Or we have a fixed routes. They have a lot of advantages because they are very, very robust for industrial usages. But in real life, why we still haven't achieved the ChatGPT moment of robots yet? Because we are missing the dynamic control. So AI-based end-to-end adaptive dynamic control would be the next step for commercial robots and even consumer robots. So I want to talk about what we do and what kind of research we're working on. So our three core technology is, number one, physical spatial AI. Like I mentioned earlier, what we do with space and physics and temporal computing. And then number two, we're working on is AI-centric sensor fusion. So a little bit different from the traditional sensor fusion. We use AI-based sensor fusion. So the AI will be, inferencing on everything it sees or perceives. And then at the end, we have our own engineered AI-platformed robotics. So it's a quadruped on wheels with DEX arms, can perform all type of tasks. So I personally believe, like, I think most people agree that too, the 3Ds for robotics are dull, dangerous, and dirty tasks. So these three things are what robotics would be thriving at. So step one would be for security, commercial security, and public services. And hopefully in the future, in 5 years, we're going to approach to getting integrated into smart cities. We are about to launch our pilot program within next 6 to 10 months. We already finished the robotic simulation. We're going to continue to build the physical spatial AI with more safety, guard railings, to pretend from anything disastrous from happening. Also, we are doing demos at how to. Yeah. So next, I want to talk about the key challenges, because we can't be all super optimistic about, it's gonna be a solution for all the future robotics. We're gonna be realistic as well. So number one, safety. It's definitely the most important thing. Like even the best AI models today, like ChatGPT 01, the hallucination rate is 1%, and they compounds. That's a major issue for robotics. When you generate a text from ChatGPT, you hallucinate 1%, it doesn't really matter that much. But if it's a robot, it's hallucinating and doing a lot of random stuff, or even potentially harming any properties, or even human, that's gonna be disastrous. So there are ways to prevent these things from happening. So our current solution is we built like one main model with agentic AI plus like self-correction protocols plus the chain of thought. And then we're adding a guard railing model to review every single motion on a higher level before they get actuated. And then next step is scalability, making sure what we're building is they are scalable. And then data privacy. So a lot of people are really concerned about like autonomous robotics privacy reasons. They'll be patrolling around, maybe recording you, and then sending all the data to the cloud, to whoever is hosting the robotics. So our solution would be all of our AI models are completely running on the edge, on the board. So we don't really need to be hooked on the cloud. They can be hooked up only on local networks and real-time constraint. So just like human, we have to react and inference in real time. Instead of that's why linking to the cloud won't work. Like ChatGPT, linking them to ChatGPT, sometimes it would take about 2 to 5 seconds to get a feedback. And if robots can't really have that much long of a latency. So I'm hoping to find all of us from Canada and Europe to join this topic and start to collaborate, because it requires the whole industry to revolutionize together. So at the end, second last slide, I want to talk about quantum classical machine learning and deep learning. I do think exploratory, like quantum optimizing hyperparameter is the future for deep learning models. So right now, most of you probably know quantum computer hardware is not quite there yet. It's still very not fault tolerable at all. But here's a little quick demo. I want to show how everyone can play around with Penny Lane. So it's a quantum simulator. It can be transferred to real quantum hardware as well. So we just basically pip install Penny Lane. And then we define our quantum circuit by choosing how many qubits you want to use. And then we define our own quantum gates. And then we design outputs linking it to a traditional classical deep learning models. And then we can integrate this hyperparameter into deep learning models with a cost function. So you can do a feedback loop. So this way you can create a quantum classical deep learning or AI. So I do think, so at the end, I want to talk about, I do think physical AI is the big next step for the next 10 years. We're just at the beginning. There's still a lot of things waiting to be developed. There are major challenges like transparency, physical common sense, real-time adaptation. And I'm hoping to find more partners and for co-developing opportunities. And we're going to create a more benchmark to test these algorithms before we can reach them to the commercial stage. So Canada just became one of the official Horizon Europe's associated country, and we're looking for any potential partnerships as well to collaborate with European Union's potential partners. Thank you. Oh, that's it. Alan, thank you. Thank you. Thank you.
We'll get you on.
Sounds good. Okay.
Well, with that dramatic drum roll that Festo have laid on for us, ladies and gentlemen, roll up, roll up. Okay, I hope this is going to be a really well-spent 20-minute presentation, and then we're going to have 20-odd minutes for a discussion, questions from the audience. I'm delighted today to bring you Mark Gilliam, who is the president of PolyUnity, Jacqueline Lee, who is the CEO. I may have got that the wrong way around, but they're fantastic people. So Mark and Jacqueline, I leave it to you to get us started on PolyUnity, the art of the possible.
Thank you so much, Mark. Thank you, everybody, for attending. This is incredible. And I want to thank NGen and Canada Makes for the opportunity to be up here today. We did a project with NGen actually a couple of years ago, a 2-year project that ended in 2023. So lots of exciting stuff coming up in our future. Maybe we can do another one. We're going to talk about 3D printing and its application in healthcare. So the Canadian healthcare system, I'm sure you all are aware of how much trouble we're in and the problems we're experiencing. There's escalating costs, there's worsening outcomes. People are taxed, we're losing our doctors. It's an incredibly challenging situation right now. Supply chain fragility. There's tankers that are not showing up. There's ships being stuck in the Suez Canal. There's increasing supply chain shortages all the time. And we're realizing more and more of our overdependence on US suppliers, especially now with the tariffs facing us. Hospitals are now looking at how completely dependent they are on US vendors and how we need to switch this. And then, of course, adoption is incredibly slow and fragmented for innovation and emerging technologies. And what we're doing at PolyUnity, I hope that we can tackle that. So as awful as all of this is, we find this incredibly exciting. There's opportunity here, and we're ready to tackle it.
Thank you, Jacqueline. So we started off talking about healthcare and additive manufacturing, and you may wonder why you're seeing a picture of the International Space Station here, but PolyUnity's genesis story actually started with 3 medical doctors who founded the company, 2 who are now surgeons. The other person was a family doctor, and we're very proud to announce he recently rejoined us as our chief medical officer. And but there was a period where they had founded a 3D print organization as they were going through their med school. And ultimately one day they were sitting down and there was a situation on the space station. And as is cliche, the astronauts called down and say, Houston, we have a problem. The issue was they didn't have the part to fix the problem on the space station, but what they did have was a 3D printer. And so engineers on Earth created the part, digitally teleported it to the space station, they printed the part, fixed the issue. And that was a huge aha moment for these 3 individuals. And they thought, wow, if we can teleport parts to space, why can't we get them in the hands of healthcare workers where they're needed, when they're needed, through the same type of distribution network, and manufacture things at or near the point of consumption? So looking at what are the foundational technologies you need to deliver something like that. And one of the amazing things we've seen, 3D printing has been around for about 40 years right now, but it's in the last 5 to 7 years that we're seeing this exponential growth curve in capabilities. And it starts really with the ability to design products, to manufacture them through 3D printing or additive manufacturing. And the ability to do that very, very rapidly in sometimes minutes and hours and days, and it's not weeks and months anymore. The ability to scan with an iPhone or another type of device to go straight to a CAD file that you can then manufacture and print. And obviously all of this is getting really enhanced with the power of AI. Digital inventory is one of my phenomenal, fascinating topics that I just love to chat about. But the concept I'm sure that we're all familiar with. When an industry gets digitized, it actually gets larger, it gets more efficient. And so this is true in the cases of things like Uber, which is the largest transportation network in the world right now, Airbnb, which is the largest hotel chain, even though they're complete digital platforms. And for any of you who are, I'll date myself, but do you remember when you would order your CDs online and you would get them come in the Columbia House package? We'd get the physical music, and you'd be limited obviously to the ones that you actually selected. Now we're in a world where all of that is in a digital inventory system, and the ability to actually get what you want when you want in real time is ever present. And the same holds true for digital inventory. So we don't necessarily need to move products all over the world right now. The concept of a digital distributed manufacturing network means that we can send that digital inventory file to the place it's needed, manufacture what we need when we need it. The other thing that's really increasing is the advanced materials engineering capabilities around the world. And we're seeing this with, advanced polymers like PEEK and PEC, even just ABS and PLA and standard polymers that we make things out of, and also the metal side of things. And we have our friends from Atlantic Excel here today who run a metal 3D printing operation in Atlantic Canada as well. And the ability to then take all of these advanced materials and create products with them that have ever-increasing strength, durability, chemical properties for heat and different types of resistance. And then obviously there's the advanced manufacturing network. And what we're seeing across the whole spectrum is almost a whole order of magnitude in increase in speed and output of production just over the last few years. So it's a 9 or 10x ability to output, which means we can make more things faster. Also, the capabilities, the quality of the output is really, really increasing. And we're seeing software automations that, again, just add to this, the ability to network machines. And then, once again, we're seeing AI come over the top of this, especially with regard to quality of output. And there are great companies right now that are working on the concept of born qualified parts, which means that these production machines will have sensors in them that look from cameras and thermal imaging and a whole bunch of sensors. So you can detect if there's a flaw in that production part as it's being manufactured to be able to tie that directly into your QMS system so you don't have to pick it up at a later part. So now we'll bring it all back to healthcare. All of these great technologies have the ability and are really transforming the way healthcare is being delivered. And we're seeing this in a whole bunch of applications. So this is not PolyUnity's kind of product set here. This is the industry-leading applications of where additive manufacturing or 3D printing are impacting healthcare. And it's everything from medical devices and products, wearables that we're going to show you some of in just a little bit, patient-specific anatomical models for pre-surgical planning. And as we start to get more and more to the right side of the screen here on your side, we're also now in very specialized facilities around the world printing with stem cells and bioinks and things of that nature to build scaffolding structures. And to be clear, this is not what PolyUnity is doing, but these technologies exist in different parts of the world. So we've went on a mission based on kind of what the three founders had envisioned to get these technologies in the hands of all healthcare workers and not just have it so that it's only in very specialized centers in certain places. And the goal to do that is impeded in some cases with some of these problems. There's 3D printers in pretty much every healthcare organization that we've encountered over the last while, but they're siloed inside of a clinical engineering department or inside of a diagnostic imaging department. So the question becomes, how do you kind of unleash that and make those machines connected? We have procurement and integration challenges. Anytime someone wants to bring a new product into a healthcare marketplace, they essentially have to sell it to all the healthcare organizations. Risk and liability that comes along with additive manufacturing, digital inventory. These are all brand new technologies. How do we deal with them from a regulatory and risk perspective? And then, we all know the burden that Jacqueline opened up with, that healthcare is under with regard to limited resources. And so the beauty part is that if we can make these technologies accessible, we can actually help to unburden them, give them more of what they need faster, and help them to be more efficient in what they do. So the platform we developed, i3D.health, is essentially, it lives the PolyUnity name. PolyUnity, in very literal terms, is defined as many as working as one, or many working in unity. And that applies to all the frontline healthcare workers having one innovative platform where they can come to get the things they need. But it also applies directly to the 3D printed products and the technologies. We want to create a digital marketplace, and are creating a digital marketplace, where we can bring best-of-breed technologies into one singular platform to allow them to have access to all of, again, for all frontline healthcare workers. So it looks something like this. We have a digital library of 3D printed parts. This is our i3D.health platform where we host those digital files. It has the ability to place orders. It's, again, enterprise level. It's hosted in GCP, Google Cloud Platform. And with that, we also have a product design service where we have professional designers that can create products. If you have an idea, or sometimes we just get people to tell us about their problems. Not all their problems, but problems that pertain to product development. And then once we've created that product, we put it in digital inventory, then they can order it when they need it, and we handle the manufacturing for them as well. And so we're working towards a fully distributed national network that can support all healthcare within Canada. And we've been challenged, and we'll answer some of these questions, I'm sure, later, as to why would you focus strictly on Canada to begin with. And we think that there's probably some challenges with that, but there's a lot of advantages to us building out this national network in Canada first. And once we do it, we then have the ability to export all of that to other parts of the world. So within the platform, without going too deep, some of you probably who have your risk hats on goes, well, you just can't take 3D printed products and put them into healthcare, and you're absolutely right, you can't. So we hold an MDEL, Medical Device Establishment License, with Health Canada, but we also have developed what we think are kind of first in industry workflows that allow you to take a product, move it through procurement approval, IPAC, which is infection prevention and control, and other stakeholders that need to sign off on the ability to use that product. So now a frontline healthcare worker can not only request a product, but we can bring it through the healthcare system for them, get it approved, put it in digital inventory, then they can order it when they need it. With that and these approval processes, we have audit trails, so who requested it, when was it approved, what does this look like, so you can come back and check at a later date. And then all the ability to do order approvals, financial billing, and of course the reporting that goes along with that. At the end of the day, this is the vision, and it's a distributed network of advanced manufacturing, additive manufacturing silos. We actually got to visit the Accenture tour just yesterday, and their 2040 report says that essentially this is the future. With all the robotics, with all the AI that we're seeing throughout this show, the ability to actually have very efficient, smaller plants distributed where we can make things at or near the point of consumption is the future. And so the thing that we're trying to do is to connect all of those so that there's an application layer at the end of the day that needs to ride over the top of this that allows someone, when they click that order button, behind the scenes there has to be enough intelligence to point that order to the nearest production facility to make sure it's done in the most efficient manner.
Okay, story time. I'm going to take you through. We've developed over 500 products now, either ourselves or are offering them. I'm just going to take you through 3 quick examples. What's our first one? Mark the bolus?
It is.
Yeah, this is we developed this for cancer radiation therapy. Traditionally, they would use a plaster of Paris procedure. They'd have to bring the patient in, probably travel from afar, have a very uncomfortable plaster cast made of their face, and then a mold made of it. Often the tumor size would change or swell, and you'd have to repeat this process. We use an existing CT scan. It's actually more accurate. We don't need to see the patient. We create a 3D printed mold, and then we create the positive wax mold, and it goes right on the person's face and directs the radiation therapy in a very targeted and effective and more accurate way. And we deliver this in 4 to 8 hours, where the other solution was days. The ROI on this, I think, is upwards of $10,000 per procedure. We do this in all of Newfoundland and Labrador right now and are trialing this in 3 other provinces. The next one.
Oh,
yeah.
Absolutely. Yeah.
Here you go.
Thank you.
Thanks, Mark. Yeah. All of it, yeah. So a lab manager in New Brunswick had a very inefficient pap smear process, a pap test. And she just explained to us what they do today. They sent us example on top of what they actually do. They use 3 different bottles of 3 different sizes, 3 different heights. They don't all fit into the tray. You can imagine sometimes it gets mixed up or contaminated, or it needs to be resampled, and it's incredibly inefficient. So we developed this 3x8 system. The actual unit is much bigger. It's in the hospital colors. There's some cool labeling on it. But it puts all 3 different size bottles in the one tray and has incredibly impacted their workflow. Upwards of, I think, 35% increased efficiency and throughput. You want to pass that around if you'd like? And our last example. This was not available in Canada when we first met these folks. So we're very delighted to start bringing this. Every osteo surgeon that we're showing this to is hugely excited. But this is a 3D printed cast that could replace traditional plaster or fiberglass casts. So Polyunity has signed a Canada-wide agreement to start to distribute this. The Active Armor folks actually help us. We scan the image here using an iPhone. We send the file off to them. They give us a printed file, and in 8 hours, we have a printed cast. So really excited to start offering this throughout Canada. Here's a quick 15-second video of the process. It's very cool. I've been wearing it.
This cast is actually customized to Jacqueline. So the scan that was done, as you can see, it conforms, and it's personalized healthcare in the fact that it's a scan-to-print application.
Yeah, so you can shower with it. It doesn't smell. You can clean it effectively, and the surgeon or your doctor can easily see and assess and track your treatment and improvement.
Yeah, there's many cases where if you had a surgery, your scar is underneath the plaster cast. It can get infected. You can't really see it. You know, it's susceptible to bacterial infection, and this is just for kids, right? Like you can get them back into sports faster. There's all kinds of amazing applications with this, so it's exciting.
So now more than ever, I think Canada needs access to innovation and emerging technologies. I think healthcare is now ready, Polyunity is ready, and this is Canada's chance to lead. So we'd love to be part of that. Thank you.
Yeah.
Are we sitting down with Mark?
We can sit, we can stand.
Yeah, no, please take a seat. Yeah, brilliant work. I'm going to sit on the end so we don't get any feedback from the. Or maybe I could sit here. Okay. Really inspiring, and I'm reminded of a saying that it's I'm not sure it's Shakespeare or whoever. Nail, shoe, horse, kingdom. For the want of a nail, the shoe was lost, the horse was lost, the kingdom was lost. And it seems to me that it would be a mistake to not understand that an entire hospital can sometimes grind to a halt for the want of something that appears quite simple. You know, all of the things we've looked at today are polymer examples. But I remember you talking about how an air ambulance may not be able to fly because a particular clip isn't present on a stretcher or something like that. So this is ultimately a value-driven proposition, isn't it, Mark?
100%. That application actually, so one of our clients is the Children's Hospital of Eastern Ontario in Ottawa, and ultimately they had a situation where they had 5 of their 6 air ambulance stretchers that were down because they couldn't pass inspection, and they were missing 3 polymer parts. And it was at a point where that CHEO hospital serves the whole Champlain catch basin in southern Ontario, and you know, losing air ambulance service for that region is life or death when you have to start to move people through road ambulance. And anyway, it got to a point where it hit the CEO. He came to us. We actually have a print production center directly in the CHEO hospital, and ultimately, in very quick terms, the clinical engineering team came to us, we created the parts, did it within 24 hours, had to send them out, get them third-party inspected and engineered, certified, brought them back in, put all of the air ambulance stretchers back into operation inside of a few days. And I guess the great point is that they haven't failed inspection since. So, that's one of those situations where you think, oh, okay, it's just a polymer 3D printed part, but when it comes to a hospital operation, with supply chain, they couldn't get the ambulances or the stretchers when they need them. It was going to take kind of too long.
So, following on from that, I'm going to quiz Jacqueline now. You said, I think, that you could maybe take 90% of the cost out of procurement, and goodness knows how much we do spend on procurement. But do you have any idea of how much money you think PolyUnity has saved really the Canadian taxpayer so far? Because I think you've got an inventory of 500 parts over a couple of years, but where are you now, and where do you think you might go to if we can build this national network in terms of, how big could this be in terms of the value proposition?
Yeah, I mean, what we sell is access and the platform. So we don't sell widgets exactly. We sell access. So I think we're going to continue to do all kinds of things that we specialize in, but we're going to go out and find those emerging technologies and those solutions that hospitals need and give it to them in a direct access way through our platform, so they don't have to individually procure solutions one by one. I think we've saved our hospitals that we're contracted with millions of dollars. We engaged a healthcare economist when we did our project in the Children's Hospital of Eastern Ontario. And through his 8-month analysis, he determined that we had a 28-to-1 ROI on average of the products that we did develop with them. And that's incredible. 28-to-1 is massive. And he looked at all kinds of things like cost efficiencies, workflow improvements, safety improvements, and environmental impacts. I think you could read any strategic plan from a hospital and you'll find innovation as a leading thing, and value-based healthcare. They all want to procure through value-based mechanisms, but not have a great idea of how to do it. So the more health economics we can use with our solution, with healthcare innovations, I think we'll be better off.
Just on the environmental side of things, if healthcare was a country, it would be the 5th largest contributor of CO2 in the world, a little over 2 gigatons per year. 70%, so 70% of that footprint is all supply chain logistics. It's actually the movement of goods around the world. So when you're sending things, again, you're sending ones and zeros between places. Yes, you have to get the raw materials there, but you can do that in bulk and pretty efficiently. Then you can kind of make the things that you need. And understanding what we're talking about here is not a panacea for all things, but there is certainly a fairly significant amount of product that healthcare, and this applies to probably all industries, that can be developed, manufactured, delivered in a more efficient way through this type of a network.
So we could save emissions because we've got distributed, localized manufacturing. I was intrigued whether healthcare will grow. You gave the examples of Uber and Apple Music and industries that have been digitized that have become bigger. And I think that's a bit of a thought starter as to why that should be. Will healthcare go the same way? How could healthcare be any bigger when we go digital?
It's not necessarily, well, bigger, but just think about it. There's lots of applications where a small, medium, and large is not the right solution. And so one of the things that this type of ability to create variations in product, so Jacqueline's example of the lab rack, a standard lab rack just does not work here. So where it gets bigger is that there's more variety, more options, more customizations that are just as efficient to deliver and produce, and ultimately it's safer, it's more effective, and better work outcomes at the end of the day.
So it's maybe more customized.
Sure.
Yeah. Okay. Absolutely. Awesome. And you talked about what we need is we have these silos right now. We need some connective tissue. Yesterday we were talking with Otto Motors, who are right behind us with their with their robots, and they were providing, the attraction to Rockwell was they were great at making machines, but the machines weren't actually connected to one another. So Otto provided literally the connective tissue there. But i3D is really the connective tissue. It's the software application that you've spent a long time developing. Can you talk a little bit more about kind of the innovation that you've had there? And you said if somebody has an idea, how are people contributing to that digital inventory, or somebody puts in a need? How do they do that?
Yeah, so one of the thesis statements I guess we had at the beginning of this, and all 500 products, I don't know if any of those belong to PolyUnity. We've helped to create them, but the thesis from the beginning was that frontline healthcare workers hold the knowledge about the problems they experience on a daily basis, and in many cases they have lots of great ideas about how to fix them. Again, the gap becomes the situation where they just don't have the tools or they don't have the time to actually go out and create those products. And so with all the advanced technologies that we kind of covered in the beginning, now you can do this more efficient than ever in the history of humanity. And so the ability to go create a new product to fix that problem and make it more efficient is, it's cost effective and it makes economic sense at this point. So what we did is we opened up an ideas portal on our platform and just got Frontline, as I joked earlier, to tell us about their problems. And this is where the first 500 products that we've created in our platform came from. And now that we've got the platform established and kind of the network and the infrastructure, now it's to the things that Jacqueline talked about bringing in. There's lots of brilliant people around the world in Israel and the US and wherever that are creating products and innovations that we could use in Canada. The challenge becomes is that if every healthcare organization has to go out and purchase all 150 of these or however many hundreds of these products and applications, it's going to take us decades. Canadian healthcare is going to suffer. Our people aren't going to get the potential coverage and the treatment that they could need. And so with a platform that can consolidate PolyUnity again, it's many as one, bring that together, and then manufacture it inside of Canada. Listen, I'm a part of the CME as well, and a very proud member. Every sustainable society ever on planet Earth has a manufacturing component to its, as part of its sustainability. And I think there's an opportunity here, in Jacqueline's closing slide, for us to reshore and do a lot more of this in a very commonsensical, economical way back in Canada.
And we're here at Hannover Messe. Obviously, we're just surrounded by all of this technology. But your point is that some of this technology might not find its way to Canada if it's a really painful route to market. If people like was Active Armor, was it the people who maybe tried and gave up, but having a centralized but distributed system will make the Canadian market more attractive, and Canadians will get best-in-class technology. So I guess that's one of the things that you're on the lookout for here as well. I know this is not an additive manufacturing thing, but it's certainly, there's a lot of metrology, there's a lot of robotics, there's a lot of AI going on. I think your point about maybe we don't need CAD technicians now to, I need something to do this. And is that a combination of, it's a text prompt to AI, it's a scan, and the previous speaker with where we see this fusion of all of these technologies, it's very exciting. I'd like, if it's okay, does anybody in the audience have a question? Let me give you the microphone.
Thank you. I promise not a real hard one. At 28-1. With what you were saying, what's the argument that you're getting from hospitals not to do this? Like, why aren't they all signed up? Why is it just a few?
It's because it's new innovation and technology, and healthcare is, and understandably so, but it's probably one of the most risk-adverse sectors in the world. And the challenge becomes is that I think the executive groups see it, they understand it, they know this is where the world's going, they want to participate. But when they have nurses and doctors that are experiencing burnout, and where do you put your dollars, and where do you actually put the resources to be able to onboard some of this, you know, it sometimes seems, I think the view is that, oh, it's another IT project, or, you know, we're out doing things when the real problem is over here. So, you know, if nothing, we're persistent, I would say. And there's lots of other easier worlds to probably pursue. But we're really passionate about the fact that, you know, everyone, right? Like, we've got aging parents, we've got children, ourselves. We all want better healthcare. We all deserve access to better healthcare. And we really strongly believe that this has the ability to move the needle significantly. But what's ultimately ended up happening, I guess, to answer your question here as well, is that we think we're hitting a bit of an escape velocity, is that every time we sign on a new client, and it's proven, because the healthcare always looks to who else is using it. So now that we're getting more and more of those clients onboarded, everyone is seeing it, 3D printing is in the news feeds all the time, and they know they had to be a part of it. And for us, a huge part of the solution development in our software was just, how do we very easily and effectively onboard a client that is already resource constricted and overburdened? And so those are some of the innovations we're actually building in our platform. It's just to make it really, really easy for them at the end of the day.
Thanks, Mark. And I'm going to leave you under the glare of the spotlight. Okay, another question from Frank.
Hi, I really love the idea. It's great. One of the challenges I see that could be happening is the ability, when you have those regional hubs and the different capabilities, how do you feel you'd address the people who would actually work the 3D printer? It wouldn't be the healthcare workers. Would they have to have special people, special training?
We see the future as a blended situation. There's lots of healthcare workers that love their 3D printers and don't want to give them up, and have all the technical skills and talent to operate them properly. The challenge becomes, these healthcare workers are typically, again, it's one person or a couple of people inside a given department. So a part of the features and the functionality that we're opening up is the ability to allow others to request services if the machine is already inside healthcare, to do that in a standardized and auditable way for the healthcare organization, so people aren't running science experiments. And then that gets supported with larger regionalized distribution hubs. If you need one of something, maybe you make that inside the hospital, or if it's very specialized to a patient. But ultimately, if you need 1,000 of something, you can do that regionally and then distribute it more effectively. So, you know, a lot of the challenges, and you've identified them, you know, very accurately, is what are the software controls? What does the interface look like to be able to make sure that those machines are managed properly, that you're getting quality of output and consistency and all of those things. So it's not straightforward, but at the end of the day, we really do think it's a blended reality of some machines inside the hospitals, and then the distributed kind of more regional network that backs that up for volume and other specialized capacity.
The project we did with NGen actually in 2023 was with Mosaic Manufacturing out of Toronto. And they have these really cool, we had a picture of it in there. They're called arrays, and it has 4 printers inside of it, and it's operated with an autonomous arm that takes the plate out and replaces a clean one. So yeah, like a nurse can come up on her to wherever it is. It's almost like a vending machine. Pick up her order, and these things can run autonomously for like 72 hours, and we can manage it remotely as well. So I think that's the future. It's like a blend, as Mark said. If it's low volume, high value, it's in the hospital, and otherwise we can handle it.
Yeah, you know, we use the concept of your inventory room is a digital closet, right? You press the button and it makes the thing that you actually want. I'm a Star Trekky fan, so like for me this is like getting very Replicator-esque, where you can kind of talk to a computer and get what you want. But it's we're obviously not, you know, atomizing physical objects, but there's a lot of similarities kind of between that, and I think the supply closet of the future, at least a significant portion of it, is digital.
Can I'm just going to jump in. I'll leave the microphone here, but it's following up on this question here. If it's such a great idea, why isn't everybody doing it? And you know, our job is to give you tough questions. So It's a two-part question. One is you can't 3D print every solution, so is your system open to all forms of manufacturing? That's part A of the question. And why stop at healthcare if this digital workflow can take so much cost out of procurement? Go for it.
So on the technical side, I would say absolutely yes. You know, during the pandemic, we actually utilized, we created a couple of additional initial projects to support because of all, well, everyone knows what happened during the pandemic. You know, global supply chains essentially shut down. So we actually took a couple of those projects, designed them, got them up and running with 3D printing, proved out the prototype, and then moved them to an injection molded process. So at volume where it makes sense, 100%. Like, you know, there's currently we're probably mostly based in the additive market, but as we go forward, you know, our goal is just to move it into the, ideally locally or you know, within the regional market space, but to utilize whatever the best manufacturing method is for that type of technology. And so, you know, we're moving into different types of machines, you know, edging our way in, I would say, into the metal side of things as well, and then relying on other experts to kind of bring that together. The second part of your question, the first part.
Why stop at healthcare?
Yeah, so, you know, given where we're at right now, we need to be myopically focused, I think, to be successful. If we try to go do energy and aerospace and automotive and healthcare, I think we're going to spread ourselves too thin. So at the end of the day, you know, for any of you who've studied market theory, we penetrate the market into, we get very specialized into a vertical, but then once you've got that up and running and it's kind of on its own, we then can pick off the next market vertical. So, you know, we'll never say never for sure. I think this platform is transferable across other industries, especially ones that are fairly highly regulated. You know, if you just want a product for your garage, you go to Thingiverse or wherever, and you can grab and print those things. But ultimately, if it's got to go through a regulatory environment to get into the actual, you know, frontline usage, we think this platform will certainly be transferable in those markets. But so it's not never, it's just maybe not now.
Anyone else from the audience at this stage? No, if not, I think I'd just like to give a huge round of applause to Mark and Jacqueline. Thank you so much.
Thank you, Mark.
Thanks, Mark. It's a real pleasure.
Thank you.
Victoria is further away to Hannover to Tokyo? I don't know. I'm trying to.
No.
Tokyo's further?
Tokyo's quite a bit further. How far? It's no, it's I think Tokyo's further. It's about, I think it's probably, well, it's from Frankfurt to Vancouver is a 10-hour flight. So,
yeah, that's.
And I think from Frankfurt to Tokyo is 14 or 12 or something.
Okay.
It's probably like, probably Dubai. No, Dubai's closer.
Did you have to take 3 planes?
Well, to get home on Monday, I'll be going Munich, Vancouver, and then Vancouver, Victoria.
Oh, there's a Munich, Vancouver?
Yeah. Wow. Frankfurt, Vancouver with Lufthansa.
I don't even know if there's a Munich, Toronto.
It's Lufthansa, but yeah. Air Canada, you often have to go through Toronto. But I'm trying to avoid that because of snow and ice and shit. So, yeah. No, there's
The ice storm missed Toronto, but just
Those are the newsworthy events that make me happy I'm living in Victoria.
I mean, I'll let you. Welcome, everyone, for our last presentation of the day from Victoria, British Columbia, via Hall 7, right there. We have my good friend Rudy of Gecko, the Green Edge Computing Corp. 100% Canadian-owned, designed, manufactured, edge computing, green edge computing, tariff-free in Canada, tariff-free in Mexico, tariff-free in Germany. Rudy, take it away.
Thank you. Well, thanks very much for coming. Can you hear me okay? I'm here to talk to you about edge computing appliances. Edge computing appliances is a new concept of bringing together everything that you need if you're not operating in a data center cloud environment. If you want to bring the cloud on-premise or near-premise, normally what people have to do is build a room or build an enclosure and put servers and switches and power supplies and everything into that. We've brought that all together into an edge computing appliance. So that's what this presentation is about. We want to enable software at the edge. We want to be able to take advantage of the technologies that have been developed for cloud computing. We have multiple vendors, we have multiple protocols. In an industrial environment, many of these vendors that are in the Hannover Fair here are operating with their independent protocols from large companies and small. We have a trend to bring a lot of these systems together into a centrally managed environment, and we need the tools for that. There are many new technologies coming out. People are talking about artificial intelligence, of course, but digital twins, you can see digital twin systems out here. We have machine learning algorithms. We have a lot of wireless interfaces in industrial automation and process automation systems. Ultimately, everything that is in the factory and industrial environment is operational technology, and there's always been a bit of a divide between operational technology and information technology. So we're trying to bridge that system as well. And one of the most important things that is challenging in an edge environment is it's often an austere environment. It's either high or low temperatures, or there's humidity, or there's solvents, or there's some problems that have to be overcome. So how do we approach that environment, and how do we bring those computing capabilities that are very valuable and useful in the cloud, how do we bring them down to the edge environment? In a conventional cloud data center, you use a lot of 19-inch rack mount equipment, and you have hundreds or maybe even thousands of these servers in such a data center, and switches and routers and everything. What we're doing on the edge is the opposite. We have hundreds or thousands of locations, but there's only 2 or 3 servers, or maybe 5 or 10 necessary in a factory environment or in an industrial environment. And those environments are almost always difficult. There's maybe challenges with temperature, or getting the temperature away from those servers. There may be problems with security, and often space is a problem. There's no location where you can put that equipment. So what we wanted to do was address all of those things, reduce the total cost of ownership. There's a high cost usually for deploying IT systems in an edge environment. You don't naturally have a data center on premise. And over the last 20 or 30 years, there's been a push to put all of the data up into the cloud. It started out small and it's become very big. Now, because of latency, bandwidth, cost, data sovereignty, security, there's a push to bring some of that back on premise and to keep some of that computing in the factory or in the facility. But where do you put it? So on the high cost, on the high end of this solution, you would build a small data center, maybe in the parking lot, or take one piece of a floor and we would build a computer room. But they're not cheap. They can cost a lot. It can be 10,000 euros for 1 square meter just to prepare it to put in one server. So that's a very expensive but necessary system that many people are implementing. If you're in a more kind of conventional industrial environment, maybe you would put the equipment in an enclosure. Not bad, but it takes up floor space. You still have challenges with cooling. Or worst case, somebody is putting some of this critical equipment in a manager's office or in a janitor's closet. That's not such a good solution. So the way we've approached this is what we're calling the edge pod. And I have one here on the table to show as well the relative size. And inside this edge pod, we have the ability to put 4 servers. This is our server. It looks like the size of a hard drive, but it is an enterprise class 8 or 12 or 16 core server with storage and memory and everything that you would expect from a large 19-inch rack mount server. It's been miniaturized. And there are 4 slots in here where you can put the server in the pod. In the middle of the server, there's a slot for a switch. So we have server capacity, we have data collection, we have storage, we have networking, we have power supply, we have security, everything that you would get from one of these rooms miniaturized into a pod. One key aspect of this product is that there are no fans. There's no noise, no fans, which is the first thing that usually fails in an IT environment. We're not worried about dust collection. We're not worried about dirt. It is all passively cooled, and that was a big part of the development of the Edge Pod, was to figure out how to bring high capability compute technology into a small space without requiring specialized power or specialized cooling. The server itself fits in the palm of your hand. It's easily 90% smaller than a typical server. We have a standard interface here. This is not something we've invented. This was developed largely by US Department of Defense in an effort to convince manufacturers to have a consistent racking system for targeting and navigation and communication systems in military applications. And so what we've done is adopted this concept into civilian applications as well, so that we can provide a multi-server, high-performance platform that can handle vibration and shock and temperature variations and so on. So that's what this is about. because it's so small and because it's so lightweight, it also uses easily 75% less energy than conventional IT equipment. And that makes it green. So the first letter in our name is green edge computing, because this is clean technology as well. It reduces your environmental footprint by quite a dramatic amount. In this world where we are, in Hannover, there are a lot of automation systems, and there's a concept of virtualizing the programmable logic controllers that are used in a factory automation environment, where we have actuators and variable speed drives, many components that have their own typically independent logic controllers to control those devices. They also run with different protocols. There might be Profinet from Siemens, for example, or EtherCAT, all of these protocols where you might buy one piece of a factory equipment came from a legacy vendor, and now we want to modernize with some new technologies. Or we might introduce some thermal cameras that have a completely different TCP/IP-based protocol, and we now need to integrate that all into a system. So the challenge is, how do you virtualize all of the programmable logic that's used in a factory environment? And the way to do it, quite simply, is in these field devices where we have programmable logic and some input-output control capability, what we can do is we can bring the programmable, a lot of benefits that come out of it. We have multiple protocols that run over a single network. There's virtual machines and containers that we can take advantage of. And this allows this concept of continuous improvement and continuous deployment, which people call CI/CD, so that you're not waiting for once every 6 months to do a factory shutdown and try the new configuration. It allows you to virtually test and implement changes in a factory environment. So this whole approach gives us a platform for artificial intelligence, for any of these other advanced control algorithms that you might want to run in a factory environment. We are working hard. We're a small Canadian startup company based in Western Canada, so it's difficult for people to understand that this is an alternative to the big guys, to the Dells and the HPs and so on, and Cisco. We're bringing all that together, but we have to definitely validate our system and how we're approaching this with the big names out there. So if you want to run Azure Local or some Amazon work flows or some VMware or any of these kind of capabilities, this is an x86 Intel Xeon. We're a gold partner, AMD EPYC, high-end servers, and we're verifying and validating that it works for all of those systems. I often am asked just what's the big difference between what we're doing and an industrial PC. So I think this kind of mini chart explains it a little bit. There's kind of a in these halls, you will see a lot of industrial PCs, devices that are designed to help with all of these automation processes. And they might run Linux or Windows or something, but they generally are a dedicated purpose device. And there's nothing wrong with them. There's hundreds of vendors, and they're very capable, often without fans, often no moving parts, very durable devices. So those are good, but they're not really suitable for virtual machines, containerized, cloud-native software. They're not really designed for that. On the other hand, those devices that are designed for a cloud environment, they're dedicated for data center use. They go in the 19-inch rack. They're very widespread, and they're names that we all know, Dell and HP and Lenovo and so on. So they're very good for that purpose. They're not really suitable for the edge kind of environment. So what we're doing with the Gecko Edge Pod is we're trying to meet the needs of that edge environment with that cloud, native cloud software capability. Anybody who's interested in this, happy to share the presentation with you. We can swap contact information. It's a quick overview. There's a couple of things here that's very important. One of them is that this design that you see here is it can passively manage about 300 watts of heat. So a typical server, pizza box size, 19-inch server, is 200 to 500 watts typically. It could be higher, but that's very common. We're only at about 40 or 50 watts with one of these. So we're easily, we're able to support 3 or 4 servers and a switch and everything within that 300 watt envelope. Now, if you're building an enclosure and a small data room, the first thing that you will be asked is how much power and how much cooling are we going to be able to accommodate. Obviously, you can put in up to that amount of compute power and you need that much cooling. Since we're limiting that all down to 300 watts, you can run this off a solar panel if you want, and a car battery. It's DC powered. It's very low consumption, low footprint, physical and everything. And that still gives you multiple servers and a switch. So it's a very unique approach at a very low power, low footprint solution. We have the ability to provide up to 8 or 16 terabytes of storage, solid state drives in a server. That's quite a lot. We can do 64 gigabytes of RAM. So this really is a fully capable server class device. Yeah, talk to me afterwards if you have any questions on all the tech specs. Where do you use this? Anywhere. Anywhere where you imagine where you're today using a server class device with 10 gigabit interfacing, 10 gigabit up speed. This is the current state of what is expected in an industrial, commercial, or any of these environments, whether it's electricity distribution, whether it's smart city, or any telecom, private wireless, content delivery, defense, aerospace environments. In North America, we're very nervous about wildfires. Canada and the United States has suffered a lot of serious wildfire problems. How do you detect them with cameras? What's the difference between smoke and fog? You know, these kinds of applications require quite advanced compute capabilities now. So we're able to provide that. And related to that, disaster recovery, disaster preparedness, and emergency response. And the bottom one is an important one. It's a micro-scale data center. So that everything you have in a small data center shrunk down to micro scale. That supports virtual desktop interface if you have an office and you need 100 virtual desktops or something like that. Put it on premise, low latency, high bandwidth, high security, data sovereignty. It's a data center in a box for applications that might be appropriate. So I think that's about it in terms of what I have to say about what the EdgePod does. I think I'm well within the limits of our time, but I'd be happy to have some conversation or discussion with anybody who's interested in it. If you need something that's resilient, rugged, and designed for the edge specifically, we can give you up to 128 virtual CPUs in one box. It's a lot of compute capability, 64 terabytes of memory. Any advanced software you want to run for artificial intelligence, virtual reality, augmented reality, all those things. I didn't talk a lot about the remote support and total cost of ownership. There's a whole other hour of conversation around that. But it is an important aspect of bringing edge computing into your facility for your purposes. I think that's about it. Thank you for your attention. I appreciate it. And wenn Sie noch weitere Fragen haben, dann kann ich auch gerne auf Deutsch das Ganze nochmal machen. Aber dann muss ich ein bisschen länger brauchen, denn meine Deutschkenntnisse sind bei der technischen Themen nicht ganz so gut. Aber vielen Dank für Ihre Aufmerksamkeit. Thanks very much. And let me know if you have any questions. Okay.
Thank you, Rudy. Any questions? Yeah, sure, Mark.
Do you have any Canadian customers who've got this installed already you can talk about?
Yes, I do. Thank you.
And the application?
Yeah,
thanks.
Absolutely. So on the front door here, we have the logo of our partner here in Germany and in parts of Europe, Ecos Engineering. They're well known for, there's two areas that they focus on, is a physical security environments. So very interested in, you have to figure out whether or not that is a dog that is coming up to a fence or if it's a human trying to get in. So physical access control, building management, building security. So that's a very active area that this company is focused on, as well as electric power distribution, smart grid, smart city. What else is there? There's all the substation automation systems, all of that, it's very, very sensitive. The information that's being processed there is very sensitive. Many of the decisions that have to be made are very time sensitive. So the concern about latency is high. The cost and the ability to provide high bandwidth connections is a challenge. You're not going to run a substation system in an Amazon workspace. That's not practical. So the idea of bringing this device down into a substation environment, industrial environment, into a building access control system, that makes a lot of sense because of all those concerns. We do have a project underway, a pilot project in Mexico, where they're working on the same thing in a substation distribution, substation environment. You have ABB bringing in stuff, you have Schweitzer Engineering bringing in protection, you have Schneider Electric bringing in metering, and all three of them say, oh, you can run our software on a server. And so they go, yeah, except for in my substation, I don't really have a rack, and I don't have air conditioning, and I don't have dedicated power. So what do I do? And so we can easily have a virtual machine for Schweitzer and a virtual machine for ABB and one for GE, and just run their software in virtual machines using VMware or Nutanix or whatever hypervisor they want to use. So yes, we have not a lot. We're still a young company. We're looking forward to building that up. We're looking for partners. We're looking for application areas. The reaction to this approach has been very positive. But yes, we have real systems up and running in security and infrastructure deployments. So,
how do you make it so small?
How do you make it so small? Well, I could tell you, but so there's a simple answer to that. Is the U.S. Department of Defense, Army, Navy, Air Force? They said, okay, we're building drones, autonomous vehicles. I don't have space for a 19-inch rack in a drone. What do I do? So they, over the last 10, 20 years, they have pushed for the development of this VPX size and standard. They wanted a small footprint, compact kind of standardized way of plugging systems in together that's vibration and shock resistant and suitable for those kinds of applications. You can go to Curtiss-Wright or a dozen companies that build defense-grade single-board computers and defense-grade communication devices, and they're very expensive because they're very expensive. But this size, shape, and interface standard is called OpenVPX. And so when we were looking at that same question, how do we bring multiple servers into a location where we cannot accommodate a 19-inch rack? There's one choice, really, that makes sense, and it was OpenVPX. So then we said, okay, how can we make it small enough and how can we deal with the heat? Because immediately that's the important part, is figuring out heat. We don't want fans, we don't want moving parts. So, and that led us to this design for the Edge Pod, where we can reduce everything down to the minimum possible size for 3 or 4 servers, because you need 3 or 4 if you're clustering you want a mini cloud, you need to have more than one server, right? You want to be able to do that. So that's how we built to that standard by identifying the right technology. We have, I mean, we say this is 100% Canadian because we are. The design and manufacturing is Canadian. We have partnerships with a company here in Germany called Contron. They make the system on module that fits inside here. So there's a lot of sensitivity about supply chain today, and so being able to partner with a German company on that end of it is very positive. So we've embraced that. That example that I showed with the virtual PLCs, that's a software solution from a company called Codesys, also here in Germany by coincidence. So, so in the automation world, in the IT world, we're working on these partnerships to bring that together, and they support that miniaturization for us. So, yeah. Thank you for the questions.
So thank you, Rudy.
Yeah.
And if you want to learn more, Gecko's booth is just over there, Hall 7. Thank you, everyone. This wraps up our day 2 on stage. Please join us tomorrow, starting at 10 a.m. We've got a great lineup, and hopefully we will see you around Hall 7 around Hannover Messe and maybe at one of NGen's receptions this evening. I think I agree. Time for a beer, and I think there's some beer on offer just down there. Thank you, everyone. Thanks, Freddie.